Good evening, everyone. We're just waiting for everyone to join in. Let's give it a couple of minutes.
Okay.
Good evening, sir. Thank you
Good
for joining in. Thank you so much for your presence.
No,
We're
pleasure.
just waiting for the people can join in. We have about 300 registrations for the session.
Okay.
And right now, 60 people have joined, but we're just waiting a couple of minutes so that everyone can join in.
Right.
Just give us a couple of minutes. We'll start now. Good evening, everyone. Welcome. Am I audible? Great. Good evening and welcome everyone to this 6-day online FTP program on generative AI fluency, which is organized by Sector Skills Council NASSCOM and sponsored by AICT Atal Academy. This program will run from 27th October, that is today, till November 1st, which is Saturday, which is 1st November 2025. My name is Kamna Jain. I work with Sector Skills Council NASSCOM, and it's a privilege for me to be coordinator for this program, and it's an honor for me to initiate this orientation session. Before we start, I would like to begin by thanking AICTE for taking up this important initiative and entrusting us at Sector Skills Council NASSCOM to host this program. I would also like to thank Dr. Abhilasha Gaur, CEO, Sector Skills Council NASSCOM, and Dr. Upmit Singh, COO, SSC NASSCOM, for encouraging and supporting us to put this whole program together. Thanks to their guidance, we have an absolutely brilliant set of resource people who are here to guide you in this journey. A quick word about NASSCOM, which is the Association of IT Companies in India. We have almost 3,800 members, companies who are our members, and we are the official voice of the IT industry for the past 30 years, delivering insights, hosting leading events, and shaping policies. And Sector Skills Council is the skilling part of NASSCOM. And Future Skills Prime is a collaboration between the Ministry of Electronics and Information Technology and NASSCOM. The course which we are going to be initiating, which is Generative AI Fluency, is provided on the Future Skills Prime platform, where we have created a group for all of you. Every day, different topics will be covered by our experts, and all the participants need to complete all these modules on Future Skills Prime. On some of you there will be an assessment on Future Skills Prime, on the Future Skills Prime platform, which you all will need to take, and the scores will be shared along with your attendance and feedback to AICTE. And you need to score 70% in the test, and 80% attendance is minimum for your Atal certificate. And you must also share your feedback on the Atal portal to get your certificates. The course is going to provide you a comprehensive understanding of GenAI and its applications, impact, and ethical considerations. So without further ado, I would now like to invite Dr. Arunabh Mukhopadhyay from IIM Lucknow for his inaugural keynote address. Thank you, Dr. Arunabh. Just to introduce, Dr. Arunabh Mukhopadhyay is a professor of Information Technology and Systems area at IIM Lucknow. He did his PhD and business management studies from IIM Calcutta, where he was awarded the Infosys Scholarship during his PhD. He has been published in various national as well as international journals. He's the recipient of the Best Teacher in Information Technology Management in 2013 as well as 2011 by Star DNA Group B School Award. He won the 19th Devang Mehta Business School Award also in India, respectively. He's a member of various committees, including IEEE, AIS, Telemedicine Society of India, Computer Society of India, Systems Dynamic Society of India, and Operations Research Society of India, and many others. Currently, he is the president of Computer Society of India of the Lucknow chapter. So it's a pleasure and our honor for us to have Dr. Arunabh with us today. Over to you, sir, for your address. You're on mute, sir.
Yeah. Thank you so much, NASSCOM and NASSCOM Skilling Initiative. And thank you, Kamaji, for inviting me to this session. So this is the need of the hour, that how do we upskill and reskill ourselves so that we are able to cope up with the new requirements of business. So I'm going to talk about this from a business point of view. So as we all understand that most organizations across the globe are going through a transformation. And what is the need of the transformation? The need of the transformation is that how do I increase my understanding about my customer? How do I reach closer to them? And how do I understand what are their specific requirements when they are trying to buy a product or when they're trying to sell a service to them? So in that context, it becomes very interesting and useful that how I could effectively use GenAI for that purpose. So that's a very interesting topic that you have chosen for this FTP, because generative AI is the one most talked about tool or technology that's been globally used, and most organizations have already started using it in some form or the other. And we as human beings and as individuals have also started involving ourselves and engaging and providing, trying to use them in some format or the others. So when I'm talking about generative AI, there are two words there, as we all understand. One is generative and one is AI. So AI is artificial intelligence, which all of us understand, wherein what we're trying to do is that we're trying to mimic a human being's activity using technology. Now, if you look at it from a broader perspective, then that means artificial intelligence is a superset under which you have a machine learning and under which you have got deep learning. So that's if you can broadly talk about artificial intelligence. Now, as we all know, artificial intelligence has been there for ages. It's been as early as 1956 or 57 when it first started coming into play. There were a lot of activities which happened there. It was known by as expert systems. I'm sure most of you are aware of it. And then we had various interesting solutions like Mycene, etc., which was trying to come up with solutions in terms of aiding the doctors to help out in creating or providing prescribed medicine or prescriptions for medicines to be administered to patients. After that, there was a AI winter, as all of us are aware of. Now, that is where all of this was only relegated to the universities, it was only relegated to the research labs, and that's how AI was happening, and it was not in the mainstream. But of late, what has happened is that from 2022, I think all of us remember that's when Chat GPT or OpenAI came into being, and it brought or made technology of AI very easily accessible and usable by all of us across the globe. And within 2 years, they had around 100 million subscribers, and all of us were trying to experiment and try to see how we could leverage and use it to our benefit. Now, in the background, what's happening, again, I think most of us are aware of, is that there are neural networks which are running, and these are large language models, as we all are aware of. Now, what does that mean? It means that we are trying to simulate or we're trying to create a look-alike of the way our brain thinks. So in our brain, as we all know, there are nerves, and those nerves are connected to each other using synapses, and then signals get transmitted through those synapses, and based on that, we are able to do reasoning. Then now, same thing has been done in the computer world, and that's where the deep learning or the artificial neural networks have come into play. And that's where we have got LLMs or large language models evolving out of that. Now, the interesting thing here is that if you look at a very simple artificial neural network, which has got, say, 5 inputs to be taken care of, and say, for example, there are 3 types of classes that you want to make the data learn, and then be able to come up with answers for that, you'll require at least a substantial amount of nodes, neural nodes or neural network nodes into it, right? So what we're talking about is that why large in the context of large models, I think most of you are aware, because we're not talking about only 5 variable solutions. We're talking about a huge number of parameters, like 100 million parameters, etc., which ChatGPT talks about, which is going to be learned by the system. And then whenever we provide it with a test set, it should be able to come up with an answer. Now, as we're just talking about the two words, generative and AI. So AI, I think we all understand, and I've just been talking about it in a very simple way. Now, the generative part is that it should be able to generate some content out after that. So what is the content? It could be text, it could be pictures, diagrams, etc. If I give it inputs of pictures and diagrams as a starting point. So that's where the generative part comes in. So that's a very interesting sort of a thing which is coming. Now, the interesting thing here is that businesses have been using it in a very big way, and all of us have been using it in some form or the other, as I was talking about. So Copilot is the most used sort of a mechanism in which we are using AI or large language models today, or generative AI. So what do I mean by Copilot? That means I'm trying to get some assistance from these generative AI tools to answer my question. So say, for example, I want to find out something about, how global capability centers in India are functioning, or why do we need global capability centers in India? What type of skill sets would a global a person who is trying to apply for a job in a global capability center or a GCC require? So that question I can pose to it, or I prompt to it, and I can get a response to it. Right? So that's how I'm using it as a co-pilot. But the interesting part here is that most of the cases we are just taking that outcome and then going ahead and progressing. So that's where it's getting only restricted to being a co-pilot. But can I take it one level up or one notch up, and can I use it as a co-thinker? So then how do I use that? So that's again a very interesting thing which many organizations are trying to get their employees to work on, that is, can it become a co-thinker? So what I do is that what response I get from the LLM, I actually challenge it and I tell it that, can you give me some references from where you have picked it up? Can you rethink about it? Can you come up with a better outcome based on the input that I'm providing it to it? So that's where it becomes a co-thinker. So once my LLM or once my generative AI becomes a co-thinker, then I get more value associated with it. So that's again a very interesting thing what organizations or businesses are trying to do with it. Now, another interesting thing is that we can take it one level up again and get more value out of it. Is that if I could use this for co-analysis, right? So say, for example, I create a design. Say, for example, I am a chip manufacturing company and I've got a design or a fabrication which I have to do, and I've created a design. Now I give it to the LLM and I ask it that whether this is going to survive, whether this is going to lead to the solution that I'm looking ahead to. Or say, for example, I have got a power plant in my, I'm a company which generates power, and I'm trying to figure out that what could be the problems in the power plant. So I give this design or this blueprint of the power plant to the LLM, and it gives me some outputs. Then I again try to give it some more insights. So it's the human in the loop, and then it gets to learn more. And based on that, I try to figure out whether it's going in the right direction or not. So it becomes a sort of a co-analysis sort of a tool. Right, so that's the interesting thing which just comes up. Now, another interesting thing which also comes up from here is that when we are talking about using LLMs, there are also a lot of interesting things around it, and I think most of you are aware of it. These LLMs are nothing but algorithms which are running based on some statistical processes which are going on in the background. So hallucination is also one big issue that these LLMs tend to do. So if I just blindly believe in LLMs to help me to provide a solution, even if it is acting as a co-pilot, not as a co-thinker, I still have problems, and which all of us would be agreeing to. And all of us have heard about examples where LLMs have gone ahead and provided a list of journal names, list of article names, etc., which never ever exist anywhere in the world. And that has led to a lot of confusion, led to a lot of angst, and led to a lot of misconception across about the use of these LLMs. We have all heard about the instance where a lawyer had created or used the help of these co-pilots and created a case for his client. But when it went to the court, the judge figured out that there were no such references or there were no such cases that he was hinting at or he was alluding to. Now, these sort of things should not happen. So why is that happening? Because we as human beings always take the context into account when we do any sort of analysis or trying to come to a outcome or a solution. But what happens here is that the context is missing. And if the context is missing, then some of these LLMs could be mathematically or theoretically correct, but it might lead to a situation where the outcomes that we are getting may be far from reality, and that's not what this should happen. Now, the interesting part is that the next phase where we can get value out of this LLMs is that, well, how do we prevent this sort of a LLM going wrong? Is that, can we get into a conversation mode? And that's what these later versions of the LLMs are trying to do, that we can converse with them, we can train them better, and as things improve, they can be more useful to us. Another interesting thing about LLMs, as we understand, it seems great and rosy, but is it supposed to, as we all know, Isaac Asimov's 3 rules about robotics, the same thing holds for generative AI as well. So is these LLMs really useful, or should be only doing things which are useful for human beings? So never ever should they go against the human beings. The moment the LLMs try to go against human beings, that could be disastrous in nature. So that's where the role of guardrails becomes very important and crucial, because if we don't have proper guardrails around GLLMs, I'm sure all of us would agree to that, we would end up in a situation where LLMs could cause destruction, could cause loss to human life as well, right? So I think all of us have heard about an example where a kid was asking, who was a bit depressed, that how he should get out of depression to a LLM, and the LLM said jump out of the window. Right? That is not what we want, right? So there should be proper guardrails around these LLMs so that the LLMs are really going to help society and in the long run be useful to us and to organizations. Now, another interesting thing which comes up with this LLMs is that the flow of logic or reasoning. So, can this LLMs help us to reason out why they are giving us that output or outcome? Right. So, suppose if I use this LLM in a clinical context, and if the LLM or this generalized AI solution tells us that a patient has got a cancerous tumor and it needs some sort of immediate attention. If that was told by a human doctor, he or she would have been able to tell us very clearly that why he is coming to that outcome. But in many of the cases, if the LLM or this generalized AI is thought to be only restricted as a black box, then these sort of reasonings don't come out. And if I'm not being able to explain to my end users that why this is happening, that again becomes a big challenge, because then it is not very clear to the end user that why this sort of a statement is made by the LLM, or why or the generalized AI solution, or why the doctor is telling him to do something of that sort. That becomes again a very interesting issue to think to be thought through, and that's where the explainability of AI becomes very important. Now, there are also another a couple of interesting things which I think all of you have seen and experienced it in whenever you engage with this generalized AI, is that there are a couple of traps that these could lead us to. One is what we saw is about fabrication, that could create content which is fabricated, which would be very far away from reality. It could also create a thing called a solo trap. So, say for example, it gives out an answer and we don't check it, and we go ahead and use it in some business context, or to take that ahead from there. Right? So that's a solo trap, because if we don't check it, if we don't we cross check and we just believe in what it is telling us, that can lead to a solo trap. So and that is not what is wanted out of it. Right? So that's where we are talking about the next phase of generative AI, which is your agentic AI, right? So where the agentic AI is what is by definition supposed to be helping us to come up with some reasoning. So output is provided, then we ask the solution that could you tell us why are you telling us this, or we could argue against it. And moment we argue, it should be able to evolve and it should be able to come up with more meaningful outcomes. So that's where the agentic AI becomes pretty handy. So that's again a very interesting component of this sort of a yeah. Now, what's happening here is that we are seeing that many organizations globally have started exploring this at various levels. So sometimes the employees themselves are using it. Sometimes the organization is using it across areas. So if it is a marketing team which is trying to use AI or generative AI to understand from the text which is being written about their products or services on social media. It could be on Twitter, on Facebook, or on LinkedIn for that matter, Twitter as in X in today's context. From there, if they're trying to infer that what type of requirements that the customers are talking about, or how good or bad they are in terms of the delivery of the products, and whether they're being able to meet the requirements of the customers or not, that could be a very effective use of generative AI. So there are n number of very interesting examples of generative AI which are in place, but there are also a lot of challenges and risks which are there, and that needs to be also addressed and thought through. So as we all know that it's the data which is the starting point. So if we have to use this in our organization, we have to have proper data in our organization. So that means automation should be the starting point. So once we have that data, the data should be clean enough, should be in a structured format, or we should be able to bring it into some format which should be analyzable, and then we should be training our models with that. And once we do that, we should be able to get responses, as we're talking about, from those models that are there, and that should help us to take it to the next level. So now, if you're talking about from a business point of view, obviously the top management of the organization would want to know that what is going to be the value that they're going to get out of this exercise, because there's a cost involved, right? So unless you're using open versions and open source AI and LLMs, so there's a cost involved to it. So if there's a cost involved, what is the benefit that they're going to see out of it? Which are the key performance indicators that are going to get positively impacted? So all of us would agree that the cost should come down because the productivity should ideally increase, because something which was taking 3 days to do should come down to a couple of hours, right? So maybe just the concept of just analyzing the data across various social media platforms and then being able to arrive at a conclusion that whether people are positive, negative, or indifferent to our products and services could be done in a couple of hours, right? So that's where the advantage comes up in a very big way. So we will have to justify the benefits that are going to come in this process. And then the next question which comes up is that is generative AI going to kill jobs? Is it going to make people redundant? That's a big fear that most of us have been hearing across various sectors of the industry. So, well, yes, to an extent, the repetitive jobs can be now taken over by AI. But if you look at it the other way around, it's the people who have to be trained or reskilled with AI. And the moment they are reskilled, there'll be n number of more jobs which would be there. And that's where the value addition is going to come in to the human being and individuals like you and me and to the organization. So it's a very interesting future that we are all heading towards. All of us are co-passengers in the same journey because it's all evolving in front of us, because we have come out of that winter and we are into a very bright, sunny summer sort of a generative AI period. And let's see how it evolves. So regulations have to be rethought, data privacy, security, all of that had to be rethought. And all these models which are there should be explainable and should be taking us to the next level in terms of ensuring that it's the humans who should be getting benefited out of it, and at no cost they should harm us. And also at the end of the day, there should be positive impact to organizations and society at large. So that's where we as faculty members have to be as fluent as possible in terms of being able to use generative AI in our own self-learning and reskilling ourselves, and then carrying it to the classrooms and using various examples, case studies, etc., being able to demonstrate that to our students so that the students are also hitting the ground running, actually. So they are, to an extent, aware of the latest developments in this space, and they should be able to use it to the fullest in whichever organization they join in as an employee. Thank you very much for this opportunity, and I'm sure you're going to learn a lot in this 7 days. Very important and very topical FTP, which has been curated by NASSCOM with the help of the Ministry of Education. So all the best to all the participants. I'm sure you're going to make the fullest out of it. And thank you so much for giving me this opportunity. Thank you.
Thank you so much, Dr. Arunab. This was a very interesting and set the tone very rightly for the entire 6 day program. As you rightly said, faculty to be able to use generative AI not just as a co-pilot, but as a co-thinker, co-analyzer, and having things like explainability, observability, and then of course having guardrails and then using agentic AI. Those are all very critical needs of the time today. And as you said that the faculty has to reskill the students. If any of the faculty members after completing the course want to take it to the students, please get in touch with me. We'll be happy to roll it out to the students as well, though I'm sure the faculty will be doing that job. So thank you so much, Dr. Aruna, and we hope to have you back for another session soon. Thank you so much.
Thank you.
We'll now move on to the first class of the session, and for which I have with me my dear friend and Director NASCOM AI, Mr. M. Chokalingam. Uh, with over 26 years of experience across content, data, and AI domains, Mr. M. Chokalingam is a tech expert bringing deep expertise spanning multiple industries, including government and the legal sector. A key milestone in his career was serving as Chief Architect AI, where he led the establishment of the Center of Excellence for Emerging Technologies for the government of Tamil Nadu over a span of 4 years. This included end to end leadership of AI strategy, use case identification, adoption frameworks, hands on development, and deployment across critical departments such as agriculture, health, energy, and education. Further, he brings hands on expertise in building ML, that is machine learning, and deep learning models, and the ability to develop a GPT style model from scratch. This includes full stack ownership from data engineering, storage, and management, pre training, all these words which you will come to know during the course of the class. So, over to you, Chalks, as we fondly call him. Please take it away. Thank you. You're on mute. You need to unmute yourself.
Yeah, that. I'll go from. Thanks, Kamna, for the brief introduction. So, to put it in one line, I always say started as a nuclear scientist and ended as a data scientist. So, that's a very one line introduction of me. Typically, when people ask me what exactly you have done and what you're doing right now. Yeah. So, I think I'm the first session today, right? I mean,
Yes, you're the first session for the entire program.
Yeah. Yeah. So we'll be thanks for this. And as Professor rightly said, right? I mean, today you are seeing a lot of people talk about generative AI, right? I mean,
you
everywhere
can
you
just
see
full
AI.
screen your screen. You can full screen your screen
Yeah.
right now. It's
Full screen.
yes, full screen. I think there's a
Thing once again. Yeah.
yeah.
It's okay.
Yeah,
So,
okay now.
Yeah. Just put this. So what I will teach you what exactly the generative AI is all about, and then educational use cases in terms of global as well as India, and then little bit on prompt engineering. I have given some of the sample prompts across various GenAI platforms, which you can, once the slide is shared, you can just try on your own. I can show one or two, and then you can type, and then you can test how it works. And then finally, what to go further, where you there is a course in future skills, so which will give in detail. Right? Typically, what is all this generative AI is? So when I do a developer session, right? What I teach them
Just
is
before
that
you start, Choks, you can just move your camera a little, scroll it down. You're not seeing, just scroll it down a little. Yeah, better. Yeah, please. Thanks.
yeah. So whenever I do a developer session, right? I mean, I always teach them how I prepared a somewhat a scribbling pad of kind of thing, which is, I think it is visible. The text are visible.
Yes, it's
Right.
visible. It's visible.
Okay. Right.
And just one more thing, I will just request all the participants. We have 159 faculty members in the call. I'll request them all to engage and understand and engage and put your questions, if any, in the chat box, in the question answer box. Put your question in the question answer box so that we can take them up as and when. So thanks.
So if you look at the GenAI in very simple term, right? I have put a very zip file kind of thing. Right? You consider this as a zip file sitting in some server, right? And the whole process of creating a language model is the zip file, right? How you create? I have put a process from creating how to scrape the data from internet, and then create tokens, which tokens is nothing but all the sentences you break down to words, and then create numerics out of it because your machine understands only numerics, and then pass those numerics to your GPU, which is your neural engine, right? And then you are creating a model, right? And there are interim steps how to remove your PII because your data security is very crucial today as per the DPDP law. So how you remove all the personal identification from your data sets, how to prepare data sets is a whole lot of data engineering you will do, and then create the data set before pushing it to the data engineering process, which is tokenization, and then embedding, and then the vectors, how you push it to GPUs. So that's all this process will finally give you the, sorry, once again. Will give you this zip file, right? And then you look at your Google, when you look at your Google interface, right? You have only a search bar, right? I mean, when you go and search there anything. Similarly, there is a search bar kind of thing in any of your GPT's site, right? Being it ChatGPT or even Gemini, you have a search bar, right? So it sits behind this search bar, and then what it does, the moment you put your input, this will figure out the nearest terms, right? It will match your words in simple terms, and then start responding to and start generating your responses and provide you the answers. This is a very simple term. That's what all your GPT does, right? Going forward, you will understand from the slides. Okay. So what see, there is an LLM and there is a generative AI. This LLM is a very broad term where it has where it can be used for multiple purpose, and one of the biggest use cases generating text, generating videos, generating audios, generating code, any kind of media, right? And then we say these are multiple. This is one of the predominant most popular use cases out of the LLM whatever we make, right? And then it has this learning capability. Continuously it learns, right? I mean, moment you start putting your prompts, it understands. That's why when you are in a login mode, right, it understands the user, and then next times it learns from your prompt also. So what kind of prompts you are using, it learns, and then when you try next time, it gives you a preferred answer or very precise answer. So it has a learning capability, continuous learning capability, and then it's create and it has a creative generation, right? Most of the marketing materials are today generated through any of these GPTs, right? It is more creative today, right? And what are the essential terminologies you should understand? People talk about, moment you talk about generative AI, they talk about tokens, right? And I said tokenization is one of the biggest process when you are before creating any of the LLMs or GPTs, right? The token is simple. It's a broken from a full sentence, and it might be such a word or a subword even, right? I mean, token, it's a logic whether a word might be a token, considered as a token, or it's broken to 2 or 3 and then it's a subword, or even character is considered as a token, right? Those are called tokens. Then there are different types of tokens. Might be an individual word or a subword or even a single character. What is this purpose? So moment you convert text into a format that easy to machine to understand, machine to process, right? Tokens are simple numeric IDs of the word. So moment you tokenize, it gives you converts the English characters to simple numerics. So which machine understands. So this is what your token does. You take a paragraph or a book, break it down to words, and then those words are converted to numerics. The final numerics are the tokens. Second, you create embedding, right? Moment you break a sentence, right? What happens? So you lose the meaning, right? I mean, the semantic part of the content is lost, right? So what embedding does? The moment you break, it retains the meaning of those passages, right? I mean, even though it is converted to numerics, what it does, this embedding is again a machine learning concept. It works simply on a k nearest neighbor. So it keeps the word and the semantic meaning together. That's embedding, right? Embedding is one-dimensional array of numbers that represents the token numerically. It creates it's again a number, but it retains the meaning of those words or the numbers, right? After the sentence is tokenized, the model uses the embedding to understand the text, right? After breaking the words, you don't understand the contextual meaning of the passage. Your embedding retains that, right? Here, there are two ways of doing the embedding. Either you can create your own embedding of all the data sets you have through any of the machine learning algorithm, or there are embedding libraries available in Hugging Face, right? You can, everybody provides, OpenAI provides their embedding, Gemini provides their embedding, right? Moment you choose your use case, right? You can, for example, you are preparing a use case for any of your engineering subjects, right? You want to teach thermodynamics. So we have to look at embeddings which are very related to science, right? Because those are very critical, because that your response comes, your embedding interacts with your LLM and generates the response, right? LLM is a very generic, what is it? It's a generic model, right? When you go to specifics, these embeddings are crucial because it gives you a relevant responses to your queries. So there are embedding libraries. Choosing embedding libraries is again they are given a very defined methodology how to choose the embedding based on the use cases, based on the responses, and based on use cases such as if it is a classification, there are different embedding libraries. If it is clustering, it is different embedding library. So embedding is again, as I said, it's a machine learning concept. So after creating your tokens, the second stage is on your embeddings to retain the meaning. Third comes your parameter, right? I mean, people always talk about how many billion parameters, right? Llama 4 is 70. This is model is 8 billion parameters, 70 billion parameters. What are these parameters values? Right? The parameters are internal weight. So what you are generating, all you push all these numerics into a neural engine. It learns the pattern of your data and produces the weights and bias. So that is what the internal weights and bias that a model learns during training a process. And then that the zip file which you see is the parameter, how much weights and biases is inside the zip file, which I showed you, right? So that's a parameter value. Number of parameters. Now, if you see, people are talking about 2 billion parameter, 1 billion parameter. So all these are weights and biases based on the data it learned. Right. Second, if you see, there is something called the scaling loss. Right. Why people are building bigger parameter? If you have more data, more compute, then the accuracy of the model is higher. So that's the famous research paper is there on scaling law, right? I mean, this these are two things which is more, you get a better accuracy. So the parameter is a critical factor in any of the model. This next thing is the context window, right? How much query it can take inside the search bar, which I showed, right? Today, earlier they started with something called 5,000 words it can take, or 5,000. Today, 10 million tokens can be accommodated, which means you can just upload a complete book, attach a complete PDF of a book, and then you can is asked to summarize. Most of the GPTs today can summarize the complete book through one single query. So that's a context window. How much the search bar can accommodate today. So that's a context window. Maximum number of amount of text measured in tokens that model can process at one time to understand input and generate a response. And that's how much you are putting inside your search bar, the query bar, whatever you are seeing. Next is prompting. Right? Prompting, today we just do a general English. Right? That's why I mentioned providing a structured input. Right? There is a method to write a prompt. So I provided a sample. Typically, each of these GPT platform have a prompt engineering guide, right? I mean, this is a very generic, but ChatGPT has a separate prompt engineering guide. Even you go to multimodal, Sora has a different prompt engineering guide. Midjourney has a different prompt. So each of these GPTs understand a specific structure or a format of the prompting. But in general, you have to write your prompt in this structure, typically a role, a task, and who's the audience and format, and finally the constraint, right? So when you give a very structured query or a structured input, their level of response, the accuracy of their response is higher. And this is in a text file. Typically, people even went ahead and say they want to do it through JSON. So most of the files, which the parameter understands, most of the language models, large language models or GPTs, understand JSON better, right? I mean, because you are giving a very highly structured input. So this is what I showed earlier is just a text file, but when you convert that to a JSON format, your level of accuracy from the model is higher. So every GPT has their own prompting structure, right? So this is one of the way to write. So rather than providing a plain English, and then structured prompt gives you more accurate results. Finally, the fine tuning. And what is fine tuning? Because there are 2-3 concepts, right? All the model which is taken from the internet and trained, they're all pre-trained, right? You get a pre-trained model, all this Gemini or OpenAI, Llamas of Meta, see, they're all pre-trained models. They scrape large scale internet and then build a model, right? I mean, if you look at the data mix of any of your GPTs, right? They say the 60 or 70% are from the common crawl, and then the rest are from book.org, and then some are from Wikipedia. And if I want to perform more on code, people go to the public repositories of GitHub and other code repositories and their training. So these are all you are getting a pre-trained model, right? Building a pre-trained model is very, very expensive, right? It takes very high GPU counts as well as very high data sets, right? If you look at Llama 4, which is again open weight model, and if you ask them for building 11 billion parameter model or 70 billion parameter model, they took around 16,000 GPUs to build, right? And which ran for 3 months. So one is time, second the GPU count, which is very expensive. That's why very few companies are building pre-trained models. But in terms of fine tuning, so you are getting a generalized version of a model, and then you want to fine tune for your use case, right? For example, you are teaching physics. You have to train the model on your data, right? It has to adapt so that you get a response for your use case, right? So what people are doing today, I take a model which is performing literally good at science, take that model, add all the physics material, right? Whatever I have, books online, combined together, or whatever notes I have. So, and then fine tune that model so that it responds precise, more accurate on the physics. So that's a fine tuning process. So predominantly all the use cases which is built by the industries are using fine tuning fine tuning any of these GPTs. So that's the use case. All the use cases today are around fine tuning. So where it happened, right? I mean, GPT is not new, right? I mean, when you say all the GPT started in 2017, and there are even before you can RNN was doing this task, right? I mean, the recurrent neural networks can even generate text, right? I mean, that was earlier, but that was not done at scale, right? I mean, it has its own flaw side for scaling. So 2017, there is one famous paper came out. It was called "Attention is All You Need." So whenever you see GPT, this image is very, very common, right? I mean, people show this is from the Transformer paper, right? I mean, the attention is all you need is a paper which brought this Transformers, which is a bigger what is the basic backbone of all your GPTs. It's from 2017. 2017 to 2018 or 19, even I can say 2020, so 3-4 years people are building models, but there are no right use cases. If you see the first GPT, it was built only on 7,000 books, and then the second GPT came with 125,000 tokens, right? Or the million or other parameters, but the use cases are very, very limited, right? And this all started by Google. What happened after 2019-20? They open source this completely to the public. Okay. If you see the older versions of all these GPTs are written on TensorFlow architecture. So Hugging Face took this and converted everything to PyTorch. So they moved to a broader Python framework, right? And then OpenAI picked it up, released the GPT-3. And then 2022, we got the Chat GPT version. Right? OpenAI just took the model and put a UI in front of that. So that's become the biggest use case, right? OpenAI didn't build the model from scratch. It was done by someone else. They put a UI. So they made ChatGPT made a biggest business case out of GPT. So but the basic architecture, whoever builds a model today, there's exactly they use the same transformer architecture, which has, yeah, as of today, this is the best architecture we have, but this has a lot of flaws in flaws too, right? I mean, that's why people are using fine tuning. Somebody is building a RAG framework. So all these other techniques which are just on top of it, they are applying to overcome the disadvantage of the basic transformer architecture, right? So it has an encoder and a decoder, just this both, right? And then how you stack this encoder decoder model, and there is all these are complete feed forward network, right? If I go to, if this is complex, you can just understand this, right? Self attention is this is our self attention, which is it's remembering the previous words and then responding, predicting the next word. All your GPTs are doing just one task. It is predicting the next word, right? Right. Whatever engineering stuff is there at the background, but it predicts only the next word, right? Self attention focuses on the most relevant word. Stack of layers learn the linguistic patterns. Positional encoding gives you the word order, right? I mean, which is the next word has been ordered, that word order. And training objective, all this training, predict the next token and learn the world knowledge. So the whole of this architecture, that's only predicting the next word through different mechanism, right? Any questions till now?
No, there weren't any questions.
Okay. So moment your GPT is done, right? I mean, people say there are three type of language models, right? One are typical the proprietary model where you get through the APIs or through a UI, which is all your Gemini, ChatGPT. These are all very proprietary model. Right? Open source model, they give you the code, they give you the data to build. So you have a model, you have the data, and you have the algorithm too. So if you want to take that and then use it for your own purpose, modify it, recode, everything you can do through an open source model. Open model is typically all your only the models, the weights and biases is available, like your, as I mentioned, Llama, Mistral, these are all open models where you can fine tune, take that, adapt to your use cases. So I get given some of the examples of proprietary model. Today GPT-5 is there. Claude 3, which is for predominantly people use it for coding, and then Opus, which is available via APIs or web interfaces on cloud. So these are typical proprietary models. Right? And these are open source model, right? A2, Falcon, these are all open source model. But people who want to work on open source model, again, this is going to be a very expensive route because you get the unbundled version of the code and then the data and then the algorithm, right? And then you add your own data and then repack, and then you need the same amount of GPUs to train. So people predominantly opt for an open weight model rather than open source model. And these are the open models currently available. Rama 2.3, today it's 4. And then Mistral, ChatGLM, FastChat T5. These are open models, which comes under Apache 2 license. And then you get only the model weights. You don't get anything else. And then you get on the technical paper of this, you get a fair idea of what kind of data they have used, data mix they have used to build the model. And then, and we all know, right? I mean, Apache 2 license, you have to, when you are deploying for a commercial purpose, you have to put the license information inside when you are delivering the code file. These are open. These are the three kind of large language models available today. Second, right, when you are building a use case, right, what kind of architecture choice you have to make, right? This is again based on your use case, right? There are encoder only architecture, which means the transformer architecture remains same, which one to mask, right? If you are masking the decoder thing, with encoder architecture, it's good for very classification task, right? Very simple. If BERT is a model which is running behind your Gmail, right? Your mail, some of the mail go to your spam, some of come to inbox, right? This is exactly done by BERT model, which is an encoder model which classifies your email to spam and ham, right? And there are encoder decoder model, which means both are available, which is used for summarization, translation, kind of use cases, right? And finally, the decoder model, which is your generative model, right? I mean, all your GPTs are only decoder models. You give an input, it generates text based on your input, right? So these are the three architecture choice inside in the transformer. So based on your use case, you can choose any of these model and then deploy for your use cases. So there are again, as I explained, right? Pre-training, there are three types: pre-training, fine-tuning, instruction tuning, and RLHF, and then RAG. Right? Pre-training is a general knowledge from large corpora, which means the entire, I mean, the web, the data scraped from the web, from books, and then from Wikipedia, or scraped and then fed into the system and built the model. So that's all pre-trained models. Right? Fine tuning is again for the adjustment domain for the domain task. Right? For if you are to build a GPT for law, again you have to add the law legal text into the large language model, and then you do a fine tuning. So your responses, your query and responses will be much related to the domain, example law or health. Right? Again, there are instruction tuning and RLHF. Right? RLHF is reinforcement learning with human feedback. That's RLHF. Right? Instruction tuning. See, when you are building a model, right? There are something technically called zero shot learning and few shot learning. Right? When you type a query and then you get a response, and the response is precise or correct, it's a zero shot learning. You didn't give any instruction. You just typed a query, it responded, right? And it gives a correct answer. So these are zero shot learning, right? Model has the answer inbuilt. So it responded correctly. And there are model which ask you more pathways, right? I mean, for example, when you are doing an algebra or a problem, mathematic problem, right? As of today, LLMs are quite poor in understanding the math logic. So you have to show them how to do this in one or two examples, and then the model learns it, and then it produces the result. These are few shot learning. Either it understands in one instruction, or you have to give multiple instructions. Right? These are few shot learning. And then there is something called instruction tuning. Right? For example, you have 10 documents, right? And then you are putting that into your fine-tuning exercise, and then you created your own database, and then that database is connected to your LLM, right? Now, when you are asking a query, you should direct them, right? Okay, for this query, go and refer this link. For this, you refer this. So you are giving instruction to the GPT to respond before response. So that's kind of instruction tuning. Instruction tuning. And what is the reinforcement learning through human feedback? Moment you instruct one time, right? It adapts, it learns, and then it starts from next time. It understands your query. It automatically go to their respective link or respective folder or respective databases and provide the answer. So that's called the reinforcement learning. It automates its process. And then and then reinforcement learning is again a separate AI exercise, which I don't want to go in detail. But through the human feedback, it learns, and then it adapts to that environment. And then when you try next time, it provides you the right answer. So that's how the instruction tuning and RLHF works. Finally, the retrieval augment generation, which means now, again, all these general models, right, works on a very specific generic queries. Right? RAG how to connect all this your data sources, right? And then make your GPT work, get the response from your data source, right? So that's how the retrieval augment generation works. Ground responses on authoritative documents. For example, you are building a financial GPT, right? Here you take any of the small size LLM and then you fine tune on the financial documents and then use as a fine tuned model. Or you can just build a RAG around this rather than fine tuning. We can opt for a RAG approach, saying I will keep this as a separate entity as a database, as a vector database. And then moment I put a query, it goes to the respective database what I created. And then I use LLM only to generate a response. So my answer will not come from the LLM. It comes only from my documents. So that's how the RAG works. So people, we have to decide when to fine tune a model, when to have a RAG approach, right? If your documents are very dynamic, then people always go with retrieval augment generation, because I keep adding the documents, the document gets vectorized and the database gets updated. The moment you put a query, it goes to the database, my database, or and then provide you a query. So these are the options available today with the LLMs, right? Either I can go with pre-training if I want to build my own GPT, or if I want to adopt a model for my use case, fine tuning, and then provide instructions, create a model through instruction tuning, or finally I can create a RAG model where my data is very dynamic and I need only responses from my own databases. So RAG is the best approach. So people, the industry is working on these fine tuning and then RAG much predominant, right? I mean, that's all the business cases are around these two areas, fine tuning and RAG. Right? And then today people talk about agentic RAG rather than every time I add a document and then create a vector. The agents take care of it. It identifies the document, push it to the pipeline, and then creates the vectors, and then push the vector to the embedding libraries, and then create the vector data. So all this are today done through agents. Right. Let's look at how this impact of GenAI in education. Right? Today, people are saying 85% of improved learning outcome. Right? And when GPT-4 came, right? I mean, there was a very famous video by Khan Academy, right? Salman Khan came with a video saying how he is teaching his kid on mathematics today or any of the subject today, right? The learning outcomes are increasing. I mean, there's a flip side, but predominantly the learning outcomes are improving because of the GPTs, chat GPTs, right? 60% reduced teacher workload, 40 million plus students are impacted globally as of today. And then a lot of edtech companies are investing today in GenAI, right? I mean, most of the, even if you see most of the LMS, right? I mean, the LMS or the learning experience platforms are AI enabled today and GenAI enabled today, right? Typically, most of the questions or assessments are auto-generated based on my learning path. These are all today done by GenAI. And I have put some more points on worldwide adoption. Leading countries like USA, China, UK, and Singapore have integrated GenAI into national education policies. I mean, we have yet to do. Personalized learning pathways, automated grading and feedback system, virtual tutoring. I mean, people are creating virtual tutors, right? I mean, to teach the relevant subjects. The model is trained on the particular subject, and then they are creating virtual tutors. And then most of them are multilingual content is generation for diverse population, right? I mean, today, as I said, if people choose an encoder decoder architecture, you can translate to any of these languages, right? Today, if you see, Llama supports 200 languages, right? I mean, if you ask me how many Indian languages are supported, I can say people claim 22 languages are getting supported. But if you see, predominantly 4 to 5 languages are strong, but rest of the things are to be done, right? I mean, the Indic language part is still evolving. So that's the adoption. And then finally, I mean, the technology integration, if you see, as I said, Khan Academy came up with FGI, so which is their GenAI platform, which is integrated in their kind of platform. Duolingo is already done, right? I mean, Duolingo is a language learning platform, right? It teaches you multiple languages. So again, it comes with AI for assessment, analytics, and then content creation, and finally early intervention for at-risk students. So all these people, the most of the edtech platforms today, popular edtech platforms are already integrated with AI and GenAI. Some of the innovation examples I have given: Carnegie Mellon, and then AI-powered language learning platform, virtual science labs, automated essay grading, and then finally predictive analytics for student service. These are predominant low-hanging use cases using GenAI. So that's why the adoption at education is very high. Right? GenAI is adopted much in marketing, now coding and education. Healthcare is coming up, but not to that level. But otherwise, these are the major sectors. BFSI is predominant sector which adopts GenAI at a very fast pace. Oh, to understand what in India, what we have done. We have done a study, right? I mean, NASCOM does a AI adoption index. Right? It comes every 2 years. The last report which came last year, right? I mean, we published somewhere in August last year. Which is the sector which adopted AI and GenAI more is we thought BFSI or healthcare, but surprisingly it was manufacturing. So manufacturing was first. Second was BFSI. Second was education. Third was BFSI, and last was in the sixth position. Last was healthcare. So education came second. So they are adopting more on GenAI, especially on assessments and then tutoring. I mean, automated tutoring or autonomous tutoring. So these kind of use cases are very predominant in education today. So we have how it is transforming the Indian education. So we recent EY report revealed 53% higher education institutions actively use generative AI in teaching, permitting students access to AI tools, right? I mean, earlier in my generation, people used to read more of books, and then Google replaced many of those books. Now Google is replaced more by ChatGPT, right? People just query and then see the response, go read, right? So that's adoption is at higher education is very high level. And then multilingual, if you see, people are looking very easily. The translation is available. I mean, Google supports close to 200 languages. And then when I want to understand something in my own language, people use Gemini as their preferred platform, right? I mean, they put a question and then say, okay, literally translate this, give the response in Hindi. It is giving the response in Hindi. So so multilingual revolution is happening, right? In terms, not only in terms of education, but also in other areas, especially in terms of government, right? I mean, there is a special platform called Jugalbanti, right? The guy, which is a non-profit. What that guy did, right? He took all the government schemes, right, for the central and the respective state schemes, and then he fine-tuned a model and gave and created a mobile app on top of it, and then he gave to all the rural people, right? And then they talk and they know about the schemes, right? Government comes with more of schemes, and people don't know. Many people are not even aware that scheme is available. If they are aware, they don't know what is the benefit and how to apply, whether they are eligible. So now people are using this kind of. I mean, GenAI has transformed those kind of use cases where people are able to understand this government schemes and then the eligibility criteria in their own language, right? And then one of the big use case, the CP grams, which is the grievance system of the government of India. So they have integrated AI, I mean Gen AI in the platform for managing the grievances, right? I mean, moment a citizen logs the grievance, so it automatically allocates, goes to the respective department, and then they get a response. So the response is generated, and then the user gets their grievance addressed. So even government started adopting GenAI in their business flows. And these are some of the Indian GenAI education success stories. CBSE AI integration. There is a Disha platform, and then AI is getting integrated there. I already done a subject to class of 9 to 12. Already they have integrated, partnered with IBM for skill build program. And then they have integrated GenAI into their system. Over 1.5 million students have access to the AI curriculum. So one is on the AI curriculum. And second, there is a CBSE mobile app for the students, right? I mean, Disha. So they are integrating GenAI to that so that people can learn, understand the topic, you can ask query and then talk to the app and ask queries about the particular topic they are learning. So CBSE is undergoing the integration of GenAI. Byju's, we all know, as AI tutor. IIT Delhi has an AI implementation for the personalized learning. And then there are NEP 2020 as the government initiative. We have the National Education Policy 2020 emphasis on integration of all education level, AI to be integrated in all education level. So that is the NEP policy, right? I mean, based on that, every section of the education is getting integrated with AI, right? How does the engineering education happens? Right? I mean, how the education is determined. So AI generated production ready. So one of the major use case what we are doing, what we are seeing at the enterprise level is like people started using copilots for coding, right? I mean, typically GitHub came up with a GitHub Copilot, and then there are specified platforms like Cursor, Lovable, Replit. These are the code assistant, right? I mean, today a person can write a single line of natural language query, and then they are creating uh, code bases, right? And even they generate code, right? Again, very simple example I can show by writing one line of code. One second. What I'm trying to show you is like how people are writing code today, right? I mean, most of the organizations are, I'm just selecting a working folder. So every, this is a VS Code, popular, what do you say, IDE, right? People work on code generation is VS Code, right? Every platform like this are today enabled with GenAI, right? It has a chat interface, right? Which is the agent, right? If I want to create a simple mobile app or an app, right? I can just write create a app. I can say even specific calculator app. In this repository, by creating the index.html, then this CSS and the script.js. Right? This prompt is very much sufficient to create an app. So immediately what it does, it creates the index.html, and people are creating websites within hours, right? I mean, that's what ChatGPT did for all the developers, right? I mean, as a developer, I feel much comfortable. So it created a index.html, right?
There are a couple of questions.
Yes, yeah.
I'll just go one by one. And so Dr. Varsha Desai is asking, what are the applications of BERT models? BERT.
BERT models, as I said, predominantly they are used for classification. Any kind of classification use cases, BERT is the model to go. The best example is Gmail, right? I mean, BERT was developed by Google, and then they integrated that with Gmail. So it identifies whether the email is a spam or a email.
Yeah,
So
and I think
any classification, BERT is the best model.
so. Basically, when we go to Gmail, it says it's a promotional email or it's a social email. Is
Correct.
that an example of BERT?
Yes, yes.
Okay.
It's a classification, right? I mean, it classifies your email.
Right. So I hope that answers your question, Dr. Varsha. Next question is from Ms. Pallavi Sakale. She's saying, what is the role of data processing in LLM? Could you please explain data pre-processing in simple terms?
Okay. So when you are getting the data, right? I mean, from internet or any of your books, right? When you start extracting those data, so first what you do, you extract your data into a readable format, right? As a machine readable format. The pre-processing involves first, it's a cleanup. The moment you extract the data, it comes with a lot of junk characters too, right? And so you are cleaning up those junk characters first, and then remove all your personal identification, right? In fact, somebody has in the data, somebody has provided their phone number or the address. Right? You have to remove those, right? I mean, those are as per the data standards. So you remove the personal identification. This one step. These are the process of pre-processing. Third, after then you are doing the warehousing stages, right? Or after that, what I will do. So then the tokenization, right? Creating the exact words or the subword. That's the third pre-processing stage. And then fourth, you remove something called stemming, right? For example, a word is spelling with ing, ed. So this you can all remove, and we have to give, because we have to reduce the compute cost, right? Let's do this. That's called stemming, right? The very famous algorithm is called Porter stemmer. People just apply that, and then it stems all the ing, ed words. Keep the single word, and then you do that. And then finally, you store it as which format the machine understands fast. Today, people predominantly use JSON. So from extraction to creating a clean JSON file with all your IDs, word IDs, and that's the entire pre-processing stage.
Thank you. I hope that answers your question.
I have a separate slide for that. When I share this slide, I'll share that too, so that you can easily read that too. I mean, all this information is there. I can share that slide.
Yeah, we in fact, it'll be good if you can share the deck,
Yes.
which we'll be sharing with the participants.
Sure.
There's an anonymous attendee who is asking, can you tell any tool that simulate the ChatGPT type of GenAI application for education purpose?
So one, see, Llama is one open source which comes with similar to GPT, right? I mean, your ChatGPT or Gemini. The thing is, like, moment you use the pre-trained model, right? Each model has a different accuracy level. There is something called model card, right? Every model releases their model card, which means how they are compared on certain tasks with a different model. So the model card is there. So you have to look at the model card, which performs better on Max, which performs better on language, which perform better on chat, which perform better on science. So they have given those accuracy levels in each model card. So look at those model card and then choose which suits your use case.
Thank you. Thank you. I'll move on to the next question. So Dr. Varsha Desai is asking another question. What is the difference between traditional classification models like RF, SVM, DT, and BERT?
Okay. So what happens when you have a very structured data, right? I mean, in row column or numerics, right? Then all your SVM RF works. When you have very unstructured data, the SVM or the RF doesn't work. You have to do a lot of data cleaning, and then the entire pre-processing steps are very high, right? I mean, how to convert word to a numeric, which they say one hot vector and encoder, and then moment you find the result, you have to trace back the results. So these are the SVMs and RFs work very good in numeric values, row column data, but BERT works on a very high unstructured data.
Thank you. Next question, I'll go to the next question. It is Mr. Satyabrat Lenka is asking, can an LLM be created using open source data and model? If yes, please explain.
So today, if you see, everything is open source, right? I mean, your data, and then if you have your own data, and then you can take your data, and then a lot of open source, as I mentioned, there are open source models as well as open weight models. If you want to, if you have the compute capacity, yeah, I have a GPU of my own. I mean, many of these organizations don't have, but I have a GPU of my own. Then you can pre-train your data, right? And then build your own model, right? I mean, you can build a complete physics GPT, or you can build a complete chemistry GPT, right? Or I can fine tune the existing model based on, as I mentioned, based on the model card. Okay, this is a model which works good on science. I'll take that model, add my own data, and then fine tune it. So you can, both are possible, and all these are open source models.
Right. Thank you for that. I hope that answers your question. There's a next question, which is Mr. Lenka is asking. I mean, I hope that answers Mr. Lenka's question. Next question is by Mr. Alanki Sanyasi Rao. He's asking, what is the basic difference between AI and generative AI?
The AI is a very broader terminology where all your machine learning, deep learning all together. Even your machine learning comes under AI today. But generative AI is a very specific. When you want to generate a new content or a new code, that's a specific use case for on generative AI.
Right. Thank you so much. Pallavi Sakale is thanking you. And I'll move on to the next question. It is Mr. Amrendra Singh is asking, how do you guarantee robustness and factual correctness in an LLM deployed in a regulated domain like healthcare law, where the cost of error is high? Good question.
Yes. So if you see the other area which we are to look at is the responsible AI practices. Right? Moment you work on specific, as you mentioned, healthcare, their level of accuracy is high, right? I mean, even 95% accuracy in healthcare is fatal. Right? So what use cases you are working on, and then what kind of models you choose, and then how you want to either fine tune or do a RAG around your model. So those are very critical, right? When I want my answer to be very precise or more accurate, I'll take a combination of fine tuning plus RAG, where I already trained my model on medical data, and then for the upcoming or the new data, I will use a RAG architecture where the LLMs dependencies are less. Right. Moreover, I get response from my own data sets, and then I use LLM only to create a meaningful understanding sentences. Just generating the response in a meaningful way, I use an LLM. So in that case, you have to choose the architecture, choose the right LLM. That's how you achieve higher accuracy, and then for specific domains like healthcare and law.
Thank you. I'll move to the next question.
And again, all these are depend upon the data sets you collect, right? Moment you are so domain specific, your data sets also to be very, very high accurate on higher accuracy side, which is bias free, which should be transparent, and then it should be explainable. So all these things comes into play.
Right. Thank you for taking that question and answering that. Next, I'll take the next question. It is from Mr. Satyabrat Lenka. He's asking, can an LLM be created using open source data and model? If yes, please explain.
Okay. So, for example, you have your own data sets, right? That's what I mentioned about fine tuning and then RAG application, right? Fine tuning is nothing but you take any of this open source or open weight model, right? And then or for your data sets, you follow all the pre-processing steps like tokenization, data cleaning to tokenization to embedding, and then storing it as a vector database, any of the popular vector database like PG vector, which is Postgres extension, or you want to go with uh, Chroma, Pinecone, VBA. These are some of the popular vector databases. So you can store your embeddings, store your tokens there or your data there as vectors, and then choose any of the open source embedding. Choose from Hugging Face, right? There is a popular leaderboard in Hugging Face for choosing a right embedding, right? They say massive text embedding leaderboard, MTEB. So if you type MTEB, the first search will be Hugging Face MTEB. So they rank embeddings there, and then you have to choose, and they put paid open. So you have to choose what is the top open source embedding, and then get that, and you can build your model, and becomes your proprietary model, your own model. This is your own data sets plus your own model.
Thank you. Thank you. I think you you already answered the next question, which is from Satya A, that can you tell the steps for fine tuning or build a model?
So building a model from scratch, right? It starts from gathering the data sets, pre-processing the data sets, and then creating tokens, all those stuff, right? When you are fine tuning, so what you are doing, you are taking any pre-trained model, which is open model, and then adapting that model to your own use case, right? You add your own data sets on top of that, your own data on top of that pre-trained model. That's fine tuning.
Right. Now, thank you.
And the pre-processing steps remain same because you have to do all the pre-processing steps for your data.
Is it possible to build an LLM without GPU? Mr. Satyabrat Lenka is asking.
No, today it is not possible because the parent transformer architecture is built on NVIDIA GPUs. So we need a GPU to build.
Right. Dr. Varsha Desai is saying thank you. And there's another question from an anonymous attendee. Sir, how much information can be shared in a prompt? Like sometimes we specify the names, college name as part of the prompt.
See, specifying any public information is always fine. Your college name of the college is fine, but the personal identifier is no, strict no. If you are asking for a student, or you are putting your address or phone number, that is strict no. So anything related to personal information, no, rest is fine.
Right. Thank you for that. And another question is that between SLM and LLM, which is better? And is it possible to create one SLM model for education purpose?
Absolutely right. SLM, if for example, SLM models works when you are building a very domain specific language models, right? That SLM is always good. Even people today say, NVIDIA recommends when you are building an agentic AI, SLM works better. But again, it compromises on accuracy. Again, because there is less amount of data, right? Sometimes it won't respond, it hallucinates. So SLM is vastly good, but it has its limitation too.
Thank you for that. Dr. Varsha Desai is saying thank you, and Mr. Satyabrat Lenka is saying thank you for your answer. We have another question. Mr. Amrendra Singh would like to ask, what novel architectural or training approach would you propose to scale an LLM from a context window of, say, 32,000 tokens to 1 million tokens while maintaining latency and accuracy?
Okay. So today, if you see most of the LLMs, right? Even the open model LLMs like Tama accepts 10 million token, right? So latency depends upon how you manage the backend, the architecture, right? How the LLM is processing. You have your base model sitting in the inference, right? These are all working. See, you train the model, your training GPU is done, right? You take the model and deploy in the inference engine, right? That is a zip file you are placing somewhere. It depends upon your inference capacity, right? People always use for example, high-end GPUs for pre-training, and then low-end GPUs for inferencing, because the or inferencing and compute doesn't happen. It takes your input and response to your query input. That's all it does, right? So if somebody train a model on say example H200s of NVIDIA, and then they keep either a H100 or A10 at the inference. So if you want to have a very low latency, your inferencing capacity to be high, right? And there are specified inference infrastructure coming up. I mean, they're in the market, right? Cerebros is one company which predominantly work on the inference side. And then there is something called Grok, Grok. Grok works on a very specified infra for
GROK, I think it's
GRK.
GROK.
Yeah. So Grok is one infrastructure providing only for inferencing. They call them as language processing units, LPUs, instead of CPUs, right? So how you design your inference, this is one. Second, how you design your cache, right? For example, a user always comes with the same question, and then what you the in-memory management typically, right? What should go to the database, what should come from the cache, right? So for example, moment I log in, right? Login should be pretty fast, right? People will not wait for so all your login information should be in cache, so that people can log in the moment I put my username password, just it logs in, right? So that kind of design. So what kind of architecture, what you keep in cache, what you keep in the database, and then how you design your inference. So these are all the critical criteria of putting more tokens and reduce more latency. I mean, reduce latency.
Right. I think there is one more question. Yeah, yes, the questions are coming in now. Dr. Vidya Mohanty wants to know, how does LLM manage its memory and database?
Okay. So LLM, there is something called or say in context, right? I mean, how much memory I need to keep. That's why I said what is in the cache. I mean, see, there is two things, right? One is the designing the language model. Second, the software engineering behind how to manage it. All this memory management are typical software engineering side, right? I mean, it's not related to AI at all, right? But if you see people, I mean, predominant practice today is all called KV cache, right? KV cache is the predominant memory management people are putting in their industries are using in their while and where, right? How I manage in cache, how I manage in my something I can manage in the cache, something I can manage in the database, right? So that demarcation you have to do. That's how we and then what something are streaming also, right? I mean, more of the data coming through Kafka layers, right? So all these data engineering principles remain same. I mean, all those practices you have to do, and then LLM just sits on top of all this.
Right. Thank you for answering that. Hope that answers your question. Next question is from Mr. Anand Na GVS. He's asking, what role do cloud platforms like Azure, AWS, Google Cloud, they play in deploying generative AI solutions?
Okay. So for example, right, when you are building your solution on-prem, right, you have to install, manage everything on your own. But Azure and then for example, AWS comes with their managed services. For example, AWS comes with something called Bedrock, right, where they provide you the GPU for training, and then they provide you inference, and then they provide whatever I show you, the VS Code kind of IDE there. So you can develop there, and they give you all the the integration through an API call, right? You don't want to build each and everything. For example, you want to build you built a model, you have to place it in a Docker. You don't want to go and install Docker somewhere, and then so you can take the Docker service and then just put your model there. Or So that's what the AWS and Azure. AWS comes with Bedrock, and then Azure comes with something we call Azure Cognitive Services. So they give everything ready-made, where you can, and they give you models also. You can choose your model. They are list all the popular models. You can choose your model. All the models are already hosted there. So you don't want to, be it open source or be it proprietary, they are already hosted there. So you have to take the API and integrate. So that's what the AWS hyperscalers are providing today.
Right. Thank you. Thank you so much. I think with that, we don't have any more questions. Please, you can carry on.
Right. So what I was doing on the IDE, I just put a one-line prompt saying build a calculator app with this. So now you are seeing a fully functional calculator with the solution. So if you want to build this through a regular code, it takes 2 to 3 days kind of thing. Now we are doing within minutes, right? So that's where the complete software life cycle, the SDLC is now changing through GPT. So there's a popular word called vibe coding. So what I did is kind of something called vibe coding, right? I typed, still people can even talk and code. You don't want to even type, right? I mean, this comes with all your voice enabled system. So if your system has a voice capability, you can just talk, and then it takes your voice and then convert to the code, and then it prepares, the software is built. So today, one of the popular thing is vibe coding. So the entire software life cycle is changing because of this vibe coding practice, which is your Copilot, GitHub Copilot, or Replit, Lovable, Cursor. So these are the code agents, code assistants, which is changing the software life. So that's one big use case people are in the industry is practicing. So what the students of computer science should learn from their from their degree, all this vibe coding, if they learn, their employability chances are very high, right? And then not only it codes, you can do a code review, you can do a documentation. You can, when I write a code, I can say, okay, give the code along with the inline documentation. It gives you all the line by line documentation of the code, and then it gives you a git push commands, how to push it to git. Or you can, if you give the GitHub access code, it even pushes to the GitHub with all the change logs. So the software, the end is the software engineering is getting changed by these GPTs, right? And there are 3D simulations that's possible through generative AI. And then all these CAT tools are now enabled with generative AI. Since all your models are multimodal, right? It understands image, it understands text, it understands video, right? The CAT drawings are done through generative AI, right? And then people are doing mathematical modeling through LLMs. And then there are performance analysis. So these are typically GenAI use cases, which is revolutionary engineering education, right? These are some of the global AI use cases. MIT, Stanford, NUS, all these people have started using GenAI in their higher engineering education. And we are and India, IIT Bombay and IIT Madras, they are started with the entire VLSI design and then automotive engineering. They are using AI and GenAI in their curriculum. So adoption has started. Somewhere it is very high pace of adoption, somewhere it is median, but GenAI adoption is there, real. So prompt engineering, I covered how to give a clear cut instruction to a LLM to get an effective response. You have to mention the specific objective, what you want to achieve, what you want to get from the LLM. And then it is iterative, right? Moment you put a prompt, then it gives you a response. You read the response, and then if it is not there, you refine your prompt, and then resubmit. So this is an iterative process, right? And today, if you see the ChatGPT 5, it gives you two kind of responses for a prompt saying, okay, which one you want to choose. So moment you choose one, so it understands your requirement, and the next prompts it refine and gives a more accuracy. So your prompt is so critical. How to write a prompt is so critical, right? I mean, it's not just general English. There is a way to write a prompt, and then all these platform like ChatGPTs and Geminis are giving their prompt guides, right? If you are even for example, Cursor or the Copilot gives you how to write a software prompt, right? I mean, I just put a general English, right? I mean, they give you specific prompt structure to create a code, right? I mean, there are various prompt engineering techniques, and then this vary platform to platform also. I have provided you some of the prompts which you can try on your own after this session. When the slides get shared, you can just put for ChatGPT, Copilot, Gemini. Notebook LM is one of the very good platform which you can show. It's again by Google, right? So what it does, so moment I can choose a PDF, right? What this notebook, this is again by Google. I can create an audio file of this PDF. So I get taken the scaling law research paper. I can create an audio file. So for example, if you don't want to read, you can just create an audio file and then listen. And second, you can create a podcast, right? And then publish. And then you can, if you are in a classroom, you can create flashcards for this paper. And then you can create mind map, right? Mind map is one thing which always gives you a very short synopsis of the paper, what it talks, right? I mean, we'll generate a mind map and show, okay, start. So it gives you a mind map, right? What are the key findings of this paper? Scaling laws, compute efficient training. It segregates the key points and gives you better explanation. So if you just keep going and gives you that. So this is one of the very popular platform for creating video from a text or creating mind map from your PDF, which you can take it to your classroom and then make the concept very easy to understand for your students, right? I mean, one is this flashcard, creating flashcards. So notebook LM, I have given some of the prompts for notebook LM. Sora is again a popular video generating platform, right? I mean, you can give some prompts and then it creates videos. Most of the videos today, what you see is created either by Midjourney or Sora, and there are a lot of other video generation platforms which are just text to videos, right? And then Manus is a Chinese agentic platform, right? I mean, what it does is like you can upload a video and then ask it to transcribe, to provide a transcript, right? It transcripts, and if you want to create the transcript to a blog page, it creates a blog page, and if you want to post it, it will post it in their own server and give you the link. So Manus is a agentic AI based GenAI. So that's again a Chinese model. So I've given some prompts you can try in Manus. And finally, where you get all this information, the Future Skills platform has a course called GenAI Fluency. It's a 10-hour course. It will give you more information on all these areas. Thank you.
Thank you so much. Yes, there are some questions. There's a question from Satya A. They're asking that please share the prompt template.
Okay, I'll do that. While I share this, I'll share the links for all the prompt templates.
If there are any more questions, please put your questions in the chat box. I think somebody has a doubt. Somebody has a doubt they wrote. Please, you can unmute yourself and share your doubt. Lakshmi. Vidya Lakshmi. Miss Vidya Lakshmi, if you can. I just wanted to check with the participants if they can put on their videos also. Because I have allowed everyone to put their videos. I just wanted to know if that is possible. Not able to. So you're not able to open your videos if you are you saying because I enabled that for all the participants, the video.
Okay, before the question comes, right? I mean, there are a lot of questions about how whether this GPT will replace my job, right? I mean, definitely not, right? I mean, there is a people are talking about AGI, right? I mean, artificial general intelligence, right? The GPT-4 will bring AGI or GPT-5 will bring AGI, nothing happens, right? So now people started understanding, right? I mean, this never replaces. That's why people create Copilot, right? I mean, it can work with us, but it cannot replace us right now, right? Yeah, I want to show you a very popular book on this, right? I mean, I think you can see the title, right?
Yes.
So this is a very popular book, right? I mean, to understand how our brain works and then how it relates to the future of AI. There's a very, I think this is 350 rupee only. Just go through this book, read, you will better understand how this GPT works and then how our brain works, and then you will have a clarity of whether the current version of GPT will replace us. Thank you.
Thank you. I think there's one more question. Please tell how to calculate how calculate app is made. And it is, yeah, I think that's one question.
Okay, so what I did typically, I just made one sentence, right? I mean, it's a prompt I gave it to a GitHub Copilot on a VS Code, which is a coding platform. It comes with a integrated uh, Copilot, which is again a GPT, which is having a chat window. I just create a calculator app in this repository. It just so for any web application, you need three things. You need a HTML file, you need a script file, JavaScript file, which is all your actions, and then the style file, right? The look and feel UI. So I just create these three files in this folder, and the app name is calculator. Just what it's a very, so when you are creating calculator is a very common app, right? Everybody understands, so your machine also understood, and then it created the app, right? If you want to build something else, you have to provide information, right? I mean, and then if you want to have a specific language, I mean, this is simply HTML, right? If you want to build something on React, you have to mention use React as the front end, and then Tailwind. So all those programming framework name you have to mention. It will create those the program in the platform in that language, or write the program in that language.
Thank you. Thank you for that. One more question is here from Mr. Ami Choksi, asking, is possible to get help of prompt for Gemini too?
Yes. So Google has published a prompt guide for the Gemini platform. How to prompt their LLMs or GPT.
Right.
So every GPT provider has given their own prompt guide. OpenAI has given the prompt guide, Gemini has given, Anthropic has given so every GPT provider gave a prompt guide, so that you get a accurate response, right? I mean, for everybody wants accurate response from the GPT what they choose. So every GPT comes with the prompt guide.
Dr. Sri Lakshmi has raised her hand. Ma'am, you may ask your question.
I think she's on mute, so please unmute.
Not able to do that. Technical glitch. Right.
So even after the sessions, you can collect the queries, and then you send it by an email. I can share, I mean, put the response and send it back to you.
Sure. So if there are any remaining queries, please send it out to us, and we'll share it. We'll share it with Mr. Chokalingam and get back to you with any questions. So thank you so much. Thank you so much for the session. Very informative, and we got a lot of feedback from a lot of participants that it was a very informative session and very easily, nicely explained in easy terms. So thank you for that.
Thank you, Kamla.
Hope
Thank
to
you.
get you back sometime soon.
Sure.
And we'll now move on to the next session, for which I would like to welcome Dr. Gopal Tadepalli. He's with us from Chennai. He's joining us from Chennai. Welcome, Dr. Gopal.
Thank you so much. Pleasure to be here again.
Good to
Looking
have you
forward
back.
to a good interaction. Thank you. Yeah.
You can just scroll your screen a little down so that, like, just little bit. Yes.
Was that fine?
Yes, it's fine now. So just for our participants, I would like to introduce Dr. Gopal. He's ex Anna University professor, and now he's consulting a lot of companies and educational institutes. He did his BE Electronics and Communications from Esmane University, Hyderabad in 1986. Then MTech from Hyderabad in 87. And he got his PhD in the area of distributed operating systems in 96 from Faculty of Electrical Engineering by Anna University. He's served in various capacities across institutes. He's published around 80 plus research papers, and he has authored books and co-edited conference proceedings. He is been awarded by Mr. Karunanidhi in 2000, and he is a consultant to several leading industries. We are honored to have him here, and look forward to hearing from him on this session. Over to you, Dr. Gopal.
Oh, very nice, Kamna. Thank you for another opportunity. Please note that I have not used the chat GPT to generate this lecture. And I'm making a simple appeal that we should never forget that it has evolved. It has evolved over a span of 7 decades. The topic that we are talking about has evolved over a span of 7 long decades. And it's difficult. It's difficult to do a review of that many years in a short span of time. We have learned some great lessons in seeing why we want machines to outperform human beings. That's not the concern at all, is what we will realize very soon. When the automobiles began to come in, were we ever concerned about the people who made a living by pulling a bullock cart? The answer is no. When any new technology came, what it was indicating is it's time to reskill. It's time to upgrade your skills. It doesn't tell anything beyond it. It only indicates, every new technology indicates that there are fresh learning opportunities. An idea which has been captivating civilizations for centuries called learning. How do we manage that learning? It's absolutely essential to understand that anything that is new, it simply means skilling, upskilling, future skilling, and I'm thankful to AICTE and NASCOM for giving me this opportunity and giving all of us an evening to spend a few hours to understand a topic that is assigned to me, Chat GPT, and its impact in education, prompt engineering. I have another session which is exclusively going to get a focus on prompt engineering. However, this session, with due regards to the designers of this curriculum, is more towards progressing on how to use this technology to really impact the education. Not merely talking about tools to generate the content and all that. Let's see if I can succeed. Your comments are most welcome. You are most welcome to differ with me on what I have been talking. Ms. Kamna, please do ensure that you are taking a look at the chat and Q&A. You can interrupt me at any point in time. I don't have a habit of reading through the entire slides. I just talk You can interrupt. The slide deck will reach Kamna very soon. The beginnings of AI is a simple question. Can machines think? The proof of concept was initialized in 1955 through Alan Newell, Cliff Shaw, and Herbert Simons, logic theorist. Logic founds many engineering disciplines. Almost all engineering disciplines are founded on logic. That remains the best bet to understand anything that we are doing as engineering. Logic theorist is a great idea that gave the first proof that the machines can think because given a set of progressive propositions, this particular theorist theoretically arrives at a possible conclusion. Yes, this is the best bet. It is not explicit, but it is able to infer, it is able to derive from a set of propositions. The logic theorist was a program designed to mimic the problem-solving skills of a human and was funded by Research and Development Corporation, RAND Corporation. It's considered by many to be the first artificial intelligence program and was presented at the Dartmouth Summer Research Project on Artificial Intelligence, hosted by John McCarthy and Marvin Minsky in 1956. Somewhere later in the slides, a decade after this 1956 start, Marvin Minsky provided a simple one-line definition of artificial intelligence, and it took a decade for him to come out with what exactly is the meaning of artificial intelligence. If it is problem solving through inference based on certain available propositions, is it AI? Is it indicator enough of thinking? Is it what humans do? All questions are open. But what they found in the summer of 1956 is a fact that many things which human beings do just almost out of instinct, almost out of, let's say, a way of working through a difficulty is proving to be very difficult to direct a machine to do it. That's definite. A child simply takes apples, oranges, keeps them separate. They're different. Very difficult for the machine to do this classification. Many things are like that. I can simply move around in a place where I am there right now and lecture and see what else can happen. But then for the machine to do this, it's very difficult. It requires step-by-step instruction, almost telling that turn right 3 degrees, move forward 3.5 meters, turn left, much like a Google map keeps talking, saying that next 600 meters you move left. When I was driving the vehicle without the Google map, it was almost instinctively done. But now I think that is an assurance of structure. What's the concern with this technology? Like every other technology, it creates a dependency and we are limited by the technology. While the goal of technology is to make sure that the human endeavor scales 5 times, 6 times than what it is, something is there in any given technology that is likely to make a human mind completely dependent and therefore limited by what the technology is promising or what it is doing. Most of the times we purchase truckload of technologies we don't use. Hardly 7 to 9% of the features of a Microsoft Word are being used by each individual. But then we are all happy to tell we are having Microsoft Word. Right now, that is what is my humble opinion, that we are just about trying to see how this fascinating 70-year-old idea has caught the imagination of so many people all over the globe, and we are willing to spend time now at large. John McCarthy, imagining a great collaborative effect, brought together top researchers from various fields for an open-ended discussion on artificial intelligence. This event catalyzed the next 20 years of AI research, and this particular 20 years spell is usually called with an acronym GOFAI. That is good old-fashioned artificial intelligence, GOFAI. This particular conference triggered 20 years of research in artificial intelligence. The best, most acceptable definition came from Marvin Minsky, one-liner. Now coming to this simple trace of a history, I'll come to a better trace later. It began in a summer. AI spring, the birth of AI. Isaac Asimov is so well noted for science fiction. Many such ideas he has injected in his fictions. Alan Turing, the man who boldly asked the question, can machines think? Arne Burling and John McCarthy. McCarthy wrote a very fascinating report about this 1956 conference, saying that it was nice. It was a very good conference, brought many brilliant scientists, but then we found that there are so many difficulties in understanding the idea called artificial intelligence. AI spring, summer. What happened, as one of the speakers, the inaugural speaker was talking, are two winters that have been called landmark winters. The first AI winter, 1974 to 1980. The second AI winter, 1987 to 1993. These two winters really saw a fantastic application of a spell of applications of AI that caught the imagination again, as much as the problem did at 75. Artificial intelligence is when machines do things that humans are assumed to be intelligent to do. They're assumed to be intelligent. We are not defining much. Marvin Minsky, 1966. He was one of the co-organizers of the first conference at Dartmouth, that is done by John McCarthy in 1956. A decade later came a great definition. Artificial intelligence is when machines do things that humans are assumed to be intelligent to do. We are assumed to be intelligent. That's it. Well, there was an AI magazine that celebrated 25 years from when, from 1980. That's happened. The AI magazine was the great idea that began close to the end of the first winter of AI. Human level artificial intelligence. Be serious, said Nils Nilsson. Nils Nilsson's work is widely regarded in giving a great positioning for this entire idea called artificial intelligence. Human level artificial intelligence. Please read the title very carefully, and you should be serious about it. The Origins of American Association for Artificial Intelligence by Dr. Raj Reddy. I helped for some time Dr. Raj Reddy in a different capacity in making this particular exercise, which he attempted for the 25th anniversary issue of AI magazine. And we got it published in CSI Communications in bits and pieces. Many things he could not include in that short exercise. AI research has endured a bumpy journey and survived two major droughts of funding known as AI winters. Please remember why the AI winters are marked out. It's a great spell. There was no fund, drought of funding, but still those two AI winters are so fantastic for the human endeavor that propelled AI. Till today we are seeing it. Particularly the first AI winter is great. What started in summer actually began in a spring, and then to summer, and then the winter. We don't want to miss the fourth season, the autumn. 1987 to 1983 is the second winter. The first AI winter was so fantastic. It's a drought of funding all over the world for anything to do with AI, and the best of the ideas started jumping out. Although the field suffered collapses in the perception of the value of AI by government bureaucrats and venture capitalists, researchers continued to make advances despite the criticism. Today, what is the story? Starting 10th November 2025, UNESCO, that's United Nations Educational, Scientific and Cultural Organization, has joined hands with the University of Oxford in offering a fantastic course, AI and Digital Transformation in Government. That's something which we should understand. UNESCO is an organization that is so de facto and de jure, both coming together. If they have given so much importance for this topic, we are all doing a great time spending this many hours learning a program on AI. So what is AI? The quest to build machines that can reason, learn, and act intelligently. Learning has always been a game changer. There's no second opinion about it. But how to make it happen? Big question. And act intelligently. I said this from MIT Technology Review. So, as I said earlier, in the first 20 years, it was good old fashioned artificial intelligence. What was that good old fashioned artificial intelligence like? The big question mark, we are only marking it out from 1955, whereas it has Alan Turing, it had Babbage, many other Blaise Pascal, so many people preceding that time. And we are running into 28. It's a very dense slide. I leave the slide deck. AI truly began in 1955. That's where AI is marked. And the man who has influenced it most is Alan Turing for daring to ask that question, can machines think? So that's where we are talking about it. 2018 is what we are talking, Edward Feigenbaum. I have used a paper written by Edward Feigenbaum very soon. Artificial intelligence emerged as a multidisciplinary perspective, but we are still looking up for an answer. What was that good old-fashioned AI that ran unabated for 20 years? And then there was a severe drought, no funding anywhere for AI, and that winter produced some of the finest ideas based on strong mathematical and statistical skills, proficiency in programming, knowledge of machine learning techniques, familiarity with data structures and algorithms, experience with big data tools, domain expertise, critical thinking and problem solving, communication skills, business acumen. This many topics make it AI and what is called the data science. There's a very good book. I liked reading this book, the national bestseller, The Age of AI and Our Human Future, Henry Kissinger, Eric Schmidt, Daniel Huttenlocher. Look at these questions which the author pose in their preface. What do AI-enabled innovations in health, biology, space, and quantum physics look like? What do AI-enabled best friends look like, especially to children? Very important questions. What does AI-enabled war look like? Does AI perceive aspects of reality humans do not? When AI participates in assessing and shaping human action, how will humans change? What then will it mean to be human? What else is required? If we can find answers, these are not readily available through ChatGPT right now. It throws out some literature survey, which I don't deny, which you can locate some good literature survey, but these questions require profound thinking even today. Very recently released book. NASSCOM has come out with a good award notification for engineers very recently, 1 or 2 days back. AI engineer roadmap. I hope they will locate somebody who is an AI engineer and see if they can nominate them. A very good idea. But then intro to AI, mathematics, programming, big data. Now I have scared a lot of people away. Are we really going to study this many prerequisites? Are they all necessary for me to progress? It appears very simple. Chat GPT, just put some words, make the prompt smart, and you'll get everything. Literature survey, literature knowledge maps, writing, citations, all these tools are working together. Elicit, Litmap, Squillbot, I've given how many? 4 into 3, 12 tools that will do everything. Literature search, knowledge maps, writing, citations. AI engineer roadmap is something that is we need to look into how to make an AI engineer happen. So instead of calling it good old-fashioned AI, I prefer using the term traditional AI. And what we are talking today, right now, and the earlier offering is generative AI. How did we move to this? Initially, when we were addressing those problems, that is the first 20 years, we somehow thought that the language which we are using to express the solution is the trouble. It's a fact of life. Pascal has very clearly proven umpteen times. Nicholas Smith designed Pascal, and he has clearly said that the language you chose to express your solution is dictating many things. Naturally, the focus went on. People have written books. We should teach computing only through Pascal or a language. Languages dominated the way we were teaching computational ideas. So here we had first machine language, assembly language, procedural language. For any domain of your interest, you can come up with a language. Unix provides great tools, Lex and Yak, to generate compilers in a flash. All that you have to do is a context-free grammar. Context-free is not taking us anywhere. AI techniques, inference languages, neural networks, many more languages will come. There's no second opinion. 700 new languages can come. 700 compilers can come. But then we are not able to address that core concern. Why? Because we realize that the hardware, which is really taking this language and then processing for us, is having too many limitations. So is this the next idea? First generation, second generation, third generation, fourth generation, fifth generation machines, we will start upgrading the machines. The machines will now start becoming more and more sophisticated. One was language design. The second one was the machines, the way we are constructing the machines. 5 generations of machines happened. Edward Feigenbaum, who I cited in 2018 in one of those traces in the history of AI, a very renowned scientist in AI lab from MIT. The Japanese National Fifth Generation Project. The world was torn between two ideas, the FGCS, which is Japanese, and the AI machines, which were pioneered, championed by the US. US has gone ahead with John McCarthy's idea of Lisp because we first addressed the language concern. That is what is dominating AI today, large language models. We have somehow thought that we can get over this language once and for all if we switch to this LLMs. The earlier language model was too constrained. We built even a hardware equivalent for that, but still it's good old fashioned. It's still traditional AI. We could scale, we could do many things. A special hardware environment, lot of dollars have been spent. World has spent machine constructing machines. In theory, you can construct a machine for C language. You can construct a machine for any language of your choice. So if you have addressed the problem of language, you can construct a machine that is in tune with that language. And if that language is solving higher order problems, you have solved the AI puzzle. That's the idea. That's the basis. For 20 long years, a lot of money has been spent. Design of high-speed Prolog machines. There were two well-known languages, Lisp and Prolog. Each one had a machine equivalent. So we first addressed the language problem, then we addressed the hardware problem. So we migrated from first generation to fifth generation, all in a span of 2 decades. That's the progress of AI. And this exercise has taught us so many lessons for the next 5 decades. Next 50 years, we are drawing from that. Today, we are in a position to tell that we have addressed that language problem very seriously. And we found a great model. The result is being experienced by every one of us today. So we are no more bounded by computational paradigms for the language. We are close. We are very close to the natural language, but let's say it's large language. Let's not talk much about it. AI has impacted society. Karanjit S. Gill is an Indian editor, 2012. This particular magazine, journal, it's a journal from Springer Nature, has come out with a 25th anniversary volume. And it was so nice that we have looked at what is to be human in the era of ubiquitous technology. It's a great volume. What is to be human in the era of ubiquitous? Karanjit Gill is an Indian, and he is the chief editor for this. Brought out a very memorable idea of a good journal. So we are answering that question very, very calmly. What then will it mean to be human? This was done 2012, but still it's a big puzzle for us. OpenAI, that's ChatGPT, has been provided by OpenAI. The chief executive officer, Sam Altman, he went on record. If this technology goes wrong, it can go quite wrong. And we want to be vocal about it. That's exactly why we are addressing this particular topic of ChatGPT in the new AI wave, saying that we should be alert. Blaming technology will never take us anywhere. And therefore, we need to be always wary. He himself was remarking in several television interviews that he's losing his midnight sleep, a completely night sleep, wondering whether we should have released ChatGPT. So that's the way we are looking at ChatGPT prompt engineering. I'll talk about it subsequently. If this technology goes wrong, it can go quite wrong, and we want to be vocal about it. That's the reason why we are talking. In fact, my commitment to NASSCOM in this topic of AI was fully formal at Anna University while I was at Anna University in a meeting on 24th January 2020. That's quite some time now, 5 years, almost 5 years, and I retired from Anna University now. Dr. Sandhya Chintala was the executive director. She is the executive director of NASSCOM. She was with us, and we put together several leaders. One of the topics with IBM at that time, which was wanting to come into this fold of FDPs and taking it to the students. Well, unfortunately, COVID stuck. Soon, next 2-3 weeks, it was COVID, lockdown. But it went in a different way, typically academic institutions. But I have enjoyed working with the leaders like technology leaders like IBM, Google, NVIDIA, Post, many things, and of course NASSCOM. I'm happy to be committed to NASSCOM on this topic, and I'm thankful for this opportunity. It has economic implications, very serious economic implications. And what I therefore look at it, instead of going through the history, instead of going through what is already documented as published literature, I have been attempting to tell that there should be single word definitions. The first stage of AI, perception. Second stage of AI, learning. Third stage of AI, deep. Fourth stage, generative. And hopefully it will become transformation. Any questions on this so far? So we have quickly skimmed through about 25 years of progress from 1956 in this field called artificial intelligence, with barely 2 or 3 real strong definitions surviving. What is AI? Still a puzzle. But then, as the new age of AI has come into being, we are asking those very important questions, and it is always good to go back to the foundations, because when things go wrong, it is what is up in the human mind that solves the problem faster. Not somewhere there on a machine. Something is there. What is the knowledge that you have at the fingertips, which are useful to solve the problem rather than hunt for a keyboard or a mouse click? Those are the ideas which we'll have to keep communicating to the students. What they are having up there with them is more important when they are really encountering a real life problem. So we move to perception. Like many simple ideas, perception was attractive. AI thought, the researchers in AI thought that after all, we are solving the problems beginning with what we perceive as a problem, what we perceive as a solution, what we perceive as what exactly is the reason why that problem came. However, maybe because the infrastructure, the hardware infrastructure was too limited. Maybe because the languages were too limited. Whatever be the reason, we have limited ourselves to addressing this simple question: what is perception, as a process of acquiring, interpreting, selecting, and organizing sensory information. So that's how we begin to perceive the real world around us. In summary, it simply means you see what you want to see in the world. There is no second opinion about it. Is it what is the world? That we'll have to figure out through really attempting a good problem, taking it up and solving, hone our skills in understanding what exactly is the way we perceive a problem, not what we want to see as a problem. That's what is the concern. That way, everything is a problem. We want to look at it. But anyway, we are very positive. We simply want to ensure that we are solution providers. And that's exactly the reason why we started looking at this problem. Perception presumes sensation, where various types of sensors each converts a certain data. To put the data together and make sense out of them is the job of the perception mechanism. So what did we do? The data gathering method is completely different. It's done by sensors. What are those sensors which are enabling a better perception? That we'll have to look into it. The data gathering is not simply determined by what we think is good enough data. What are good enough number of fields? No, either driven by application or what we think. It is driven by what the sensor is doing. As a special type of categorization, classification, where the inputs are sensory, these are standard definitions. Inputs are sensory data and the outputs are categorical judgments and conceptual relations. As I mentioned earlier on, Nielsen came out with a great paper, Shaky the Robo. So it's a good idea. The name itself is good. He created a robo in his laboratory and called it Shaky. We don't do things in a shaky manner. We are very firm-footed. We are very firm in actions. But then this very idea, the name Shaky, was so captivating that people began to look at it. It makes categorical judgments, but then it's very shaky. The difficulty of the task comes from the need of multiple levels of abstraction, where the relations among data items are many-to-many, uncertain, and changing over time. That is the challenge. Many-to-many, we are not good on this mapping at all. This relation many-to-many has been a puzzle for many students of algebra. Uncertainty and changing over time. Those are the watchwords. Anything can map onto anything else. What's preventing us? That many-to-many relationship is very, very challenging, intellectually stimulating. We never see things as they are. As we keep talking, 100% of human thought is approximation. You may challenge, you may talk about it. 100% of human thought is approximation. What we are attempting to do with machines, learning, education, training is, our future skills is, to ensure that it is not a trivial approximation. If we succeed in doing this, we have succeeded to a large extent in enabling people to learn on their own, set their eyes, set their visions high, and progress. So, perception process of intelligent system is often influenced by internal. I'm not going to read it out.
Yeah,
In AI,
Dr. Gopal, are you showing your screen? We are not able to see your screen.
My goodness, I didn't realize it was shared, I thought.
Are you able to share? I'm not able to see your screen. I wanted to see if others can see your screen.
I don't know.
Yes, I can see it now.
Okay. So, do you want me to just take a quick walk back on the slides?
No, that's fine. I think there are no questions, so you can just move forward from here.
Oh, very good. Types of perception: hearing, vision. These were the two major ideas that were technically feasible, that were possible to work on, And we have begun with hearing and vision, whereas sensory is much more intricate, much more profound. We stopped on these two ideas for quite some time. Speech recognition is the front end of a system that can perceive and understand spoken language. Once again, language. We strongly believe that language holds the key. Language will hold the key. But then, what was that language like? Not a context-free grammar that required a lexical analyzer, that required the compiler, how to do it. Those were perhaps not the ways in which language is meant to work on the human. Are you still seeing the screen, sharing the screen? Yes? Hello? I need a feedback on that. Is the screen shared? All right, good. Okay, thank you so much. I got the chat feedback. Very nice. Thanks a lot. Hearing, perception, speech. It is good at one end to think that the natural language is the best. We simply look at one another and go ahead. There is no need for any further dialogue, any further conversation. Oftentimes we keep repeating as we watch the cricket match, they just cross over for the single. No series of commands, no series of exercises. And we can simply give a verbal instruction and we do many things which are so advanced. The idea of language was bothering us from quite some time. And we think that now we have a very, very comprehensive way of addressing that particular problem of language. However, please do remember what Altman has said. I would want to go back to that single slide. If this technology goes wrong, it can go quite wrong. And we want to be vocal about it. Please relate it very carefully. Every word is very important in what he said. So we are really looking at understanding that speech recognition is the front end of a system that can perceive and understand spoken language as used in voice command interface and speech-to-speech translation. Where is the equipment for that? We never had anything more than a keyboard. One is the language, the other one is the equipment. So you see how we have addressed the language problem and the machine, capabilities of the machine. So it is easily understood how we progress from first generation to fifth generation of computing systems. Several approaches towards speech recognition, acoustic, phonetic approach. Lot of research has gone in acoustic, phonetics, pattern matching, AI approach. Specific algorithms have happened. Speech is one of the finest ideas that we have ever addressed, and we addressed very, very calmly, very, very carefully. Still, the problems are not solved. We have had many ideas. Is this the model of a language? Is phonemes the secret of the language? Are we really going by those phonemes that are guiding our neural networks and making us understand? Difficult questions to answer. Are we talking about words? Are we talking about sentence constructs? What is it that we are talking about? How do we process language? Very big question. Please understand that AI is still a very, very challenging multidisciplinary approach where we have found answers to those two basic questions. Is language the barrier? We seem to have broken that barrier with large language models. Is the machine, the sophistication of the machine, the answer? Should we build sophisticated machines based on, let's say, fifth generation languages like Lisp and Prolog? The answer is no. We can have better things, as you and I are seeing every day now. Simple machines, my laptop is connected to ChatGPT. However, to analyze our large language models, you do require high-end machines, supercomputers, vector machines. I myself have a login to a cluster of 4 very high-power machines. I was a member of I am a member of Open Power Consortium, and we got some computer time purchase at $10 or something. You can purchase a high-end machine time to try out what is this LLM. What are the internals of that LLM? I'm not really wanting all people to do 7 PhDs or 8 PhDs in AI. No. But then we should know where to fall back on at the earliest. Pattern matching, artificial intelligence approach. Postulates that there exist finite distinctive phonetic units in spoken language, that these units are broadly characterized by a set of acoustic properties. Limited scale, you can simply keep experimenting with what is called Alexa. It breaks the spoken language very nicely. Even 25 years back, the advanced television sets had spoken language interface. You can simply tell, I want to go to channel so and so. It connects you to channel so and so. I want to find out in which programs this particular person is appearing in 10 channels. It will tell that. It's a case of consumer electronics where even a dollar increase in the price of a component will manifest as $100 increase in the final product, which may keep the product out of the market. Very hypersensitive. Consumer electronic market is hypersensitive. Therefore, we think that a limited exposure to spoken language has reached many homes through this nice device called Alexa. It's so fantastic. And most of the televisions today at home do take voice interface. There were vocoders 30 years back, and we found that it is not merely the signals, the speech signal, the frequency. Later on, some of the lectures are talking on music. In the last offering of this course, a very good talk on music. I attended that talk for a few minutes. And it is not merely the frequencies, because it takes phone in the frequencies. That's what electronics is extremely good at picking. What is speech? What is language? Difficult questions to answer. So what we have done is, instead of addressing so much of the speech, we attack the number one problem which we have been grappling with since the first generation of languages. Most of you are seasoned teachers. First generation of language, the cumbersome machine language. Ever since, language was a serious challenge for us. We can design a language of our choice. We can design a language with specific terms. As a matter of fact, while in MTech, for the part of our project, my project mate and I came up with a language called Bool to describe what was called the hardware. We talk in terms of registers, we talk in terms of capacitors, and we had a Lex and Yak provision. We built a simple compiler and presented it in a VLSI design conference. It doesn't take long to define a language of our choice, but then that is proving to be restrictive. The language determines the way we are going to solve the problem and express the solution. Therefore, we attacked that problem first, created a large language model which is keeping us up. We have built the new way of AI, which is generative AI. This large language model is so attractive because it not only breaks the given thing and tries to do something, but it generates text for us. It generates content for us, not only text, multimedia. Please do go through all the 30 plus modules in your login ID for this AICTE-FDP. You'll understand that there are many such things that are possible around this idea called large language model, which is generative. So from the traditional AI, we attacked the language problem first. And we came out with a large language model, which is now the next wave of AI called generative AI. But remember, all this happened over a span of 7 decades. We are not really looking at the acoustic properties of the phonetic units anymore like we were before. That's an old model. We're not talking about acoustic phonetic approach. Then what are we doing? Pattern matching. That's probably what Alexa is demonstrating. It matches some patterns. It tunes well, and it gets some keywords. Is it the keyword or is the big idea? Are we looking at a pattern of the keywords? Difficult question. A direct comparison is made between unknown speech, the speech to be recognized, with each possible pattern learned in the training stage. So we have overcome all these. We said we are not dependent on a speaker per se. There is something else. There's a pattern that tells me this is most probably the command. That's what we have been talking. Attempts to do speech recognition using various AI techniques like knowledge-based systems. So we have come a long way in addressing what we called the speech out of the sensory perceptions which we wanted to really emulate on the machines. We have shown quick but very limited progress on acoustics and vision. Speech synthesis, text to speech, after the text analysis capabilities, we have been looking at all these ideas influencing us, but then they have not impacted us as a bundled idea of AI, largely because it is still wanting us to focus on, tell me what are the ways in which you can express what you want the machine to do, at which level, at which generation of the language. After the text analysis capabilities, pre-process the text, digit sequences, abbreviations, the pronunciations of most ordinary words and proper names. Finally, there are methods responsible. Is this the way we want to go? Can we understand what the LLM is doing by simply reading out a few words and capturing it? Today, that interface is there. It's just open source. You can just interface to that. You don't have to type into the chat GPT at all. You can simply do that. It generates speech. We have spoken about the AI characters speaking. All these have been well studied. It is not something that's happening yesterday, but then we need to understand how we progress in meeting the first ever challenge we had with the machines. What is the language to command the machine to do what I want to do and do nothing more than that? Exactly what I want. That's still not assured. We are still not able to communicate to the machine to do exactly what I want, but it does. It more or less meets my requirements. A major remaining problem is naturalness. That's the concern which we are having. I've been mentioning this in my talk. Where is that naturalness? For that, we need a better language model. Naturalness stems from emotion, stress, tone. To fully solve this problem, it's probably necessary to fully understand the meaning of the message and purpose of the speech. The speech interface to the generative AI is still a long way to go. But then we know we have some speech interfaces. We have been toying with that idea. It is not frequencies, it's not sampling rate. It is something more. Speech naturalness is something more, but then we are able to get a language model which is able to take on the natural language in an unprecedented manner. It's a generative AI. That's what is keeping us completely engaged of late. Music perception and composition. There are good modules in the course material provided for this FDP. You can still read through. There's another lecture coming in. Music perception and composition are also studied in AI. Music works produced by a computer program because it's generative. It can generate music. Can you tell the difference between what's a computer generated? Very difficult. Computer generated music and a regular music becoming very difficult. People are not able to give a judgment on that. So this is where we started. We started with speech because one, we were really finding it difficult to first phrase what we want to do in a manner which the machine understands. Second, take to a keyboard, keypad and punch the command. So we were wishing that the machine can have some speech interface. It can hear, hopefully. More than calling it speech, we called it hearing. How nice it will be if the machine can hear, like you and I do things. That kept us really wondering about many things, like I have spoken. A good research area, speech, acoustic, types of speech, all this. Then came the next one. Can the computer see? Vision begins with a large array of measurements of the light reflected from the object surfaces into the eye. Again, it's a perception. It's not thinking, it's perception. What hits the eye? Analysis then proceeds in multiple stages, with each producing increasingly more useful representations of information in the scene. Computational vision. Early representations may capture information such as location, contrast, sharpness. We still don't have a fascinating model like a large context model. Imagine, all of you, after completing this course, will have good groups of students and attack that problem. Where is that large contextual model? So we are very good on context free. There's no second doubt about it. The language per se was a problem. How to express it, how to feed our commands, those two problems were addressed first. First generation, second generation, third generation, up to fifth generation. But that's not a solution. Spent a lot of money, dollars. But then some of the best ideas also came during the winters, 2 winters, not one, 2 winters. Early represented, one of the speakers who spoke, I think it was the inaugural speaker, he was mentioning it very clearly, the winter. That's the time when human was challenged, the research was challenged. It's all done away with. But then we produced a miraculous way of coming back into the game. Early representations may capture information such as location, contrast, and sharpness. How large is the context? That's the next challenge in vision. In language, we came up to this point. Very cumbersome to command, type the commands, type the language statements, and simply speak the commands. There was one very good machine, early machines, way back in 70s, 80s, called Diddley. It was taking voice input, but Alexa is much more amenable for all of us. We easily understand. Such changes correspond to physical features such as object boundaries, texture contours. We are still not able to get that large contextual model. We are doing it on the language. The machines have improved in a sense that we don't know, we are not looking at language specific machines, Lisp and Prolog machines. That's a bygone era. We are quite happy with very, very powerful machines, the supercomputer machines, clusters of machines. There is no depth of computing power. Everywhere, just $10, you get a fascinating computer power to analyze. But are we building a large context into it? Big question mark. That's the next challenge. As I said, I'm not reading the slides. I'm trying to be different from what I really wanted as a sequence, in a way, in some manner, but it's a flow of a lecture. Texture contours and marking on object surfaces, shadow boundaries and highlights. How much of this are we able to capture? Large language model is not enough. We need a large visual model. Where is it coming from? The generative AI can become transformational in this spell if we can add such puzzles, such problems to answer better questions, to answer more fundamental questions, I would say, not better questions, to answer more fundamental questions. Intermediate representations describe information about the three-dimensional shape of the objects. Such representations may also describe, it's just a case of representation is what we have been harping on. Everything is like that, knowledge, representation. Time has been spent, money has been spent on how to represent the knowledge so that the machine can work on it. That itself is a big puzzle. Much like what we have been talking about in data. How do we capture sufficient data for managing a database, for managing an application on hand? So all those problems are now somehow vanishing. We are no more worried about the sheer volume of the data. We are no more in quest of high computational power. The thing that has triggered this wave is what we call generative AI, is a large language model, LLM. And you have to simply prompt, and that prompt can be vocal, but it's a limited prompt. That I'll talk in the next lecture. Very limited prompt. The puzzles and challenges for all of us in faculty development programs are like this from now. That's what I mean when I tell that if you are investing on this machine, the human power must increase fivefold. We have a direction that talks about building large context. How do we do that? It's no more the representation. We have to think that's a challenge which we are having ahead. Higher level representation. We have spent a lot of time in capturing an image, seeing what it is, analyzing, segmentation. All techniques are known. Image processing was a great topic when I was beginning my research, and we were doing it very nicely into using mathematical models called matrices. Then came computer graphics, which shifted plenty of that mathematics into using those language devices like pointer, mouse, click, language commands. Computer graphics is more programming oriented, whereas image processing is more mathematical oriented. Your choice. There's a vision that we are talking about as a subject of matter, of serious interest. So the first 25 years or so, we have been talking about only two sensory ideas: acoustics, vision. Lot of research has gone. Why did they hit a summit? First, again, we said the language. We are not able to communicate to the machine the richness of a human thought, which makes us do wonders with other human beings. We are coercing whatever we are thinking into some sequence of fancy commands, typing them in, very cumbersome, and the machine is churning out. By making the machines better and better and better and costlier and costlier and costlier, we still hit the summit. It's still not serving the purpose. So where is the solution? Presently, the LLM has caught our imagination. It has addressed a very core concern, very important, very core concern called language. Still not really reflecting the full naturalness, but it is giving us that flexibility which each of us are experiencing. This entire week, you will study how that LLM has triggered a brilliant wave of AI, which we are going through. For relatively simple pattern recognition, why do you want to do so much? We should do something for a better idea. CAPTCHA is commonplace. Very, very recent times, CAPTCHA was a very nice project. 10 years, 15 years back. But today, everywhere it's CAPTCHA. OTP generation was a big project. That's how we are. At one point in time, it was capturing our attention span. Now it's commonplace. Very soon, the wave is likely to give way to better questions, like what that new age Henry Kissinger's book talks. Better questions. We have to ask better questions. We have to project ourselves for the next 10 years. That's how we should push ourselves. Invested in one machine today is a promise that we'll improve ourselves 5 times more. It's not about loss of jobs at all. As I said, when the automobile came, the bullock cart rider did not vanish. They simply upgraded their skills. Every technology is a harbinger of a spell of learning at large, which is very important. We are becoming more and more literate with every new technology coming in, which is the crux in ushering in these technologies. Eye movement has important impact on human visual perception. I worked with two eye trackers. It all began with Stanford research on eye tracking, eye movement, active vision. The point is, human eye picks a brilliant context. How and why, I don't know. We'll have to answer from tomorrow. I may not be able to express it I don't have a large language model to express it. I have a limited repertoire of a natural language. But still, the problems are there, which are so easy for me to solve, very, very difficult for the machine to emulate. Still a long way to go, but then it's generative. It picks what is to be done and writes an essay out. An active, again, I must mention that none of these slides are picked out of ChatGPT. I have not used ChatGPT or any of the AI tools which are nicely described in the material. I implore each of you to go through that material to see how it is reflected in all those nice lesson plans that are there for this course. Good to have that lesson plan active in your minds. An active vision system is one that is able to interact with its environment by altering its viewpoint rather than passively observing it, and by operating on sequences of images rather than a single frame. This is the secret of our success. We influence the environment. It's a proactive idea. There's some study on using the eye gaze on the computer user. Many studies are there. I worked on two eye trackers, Toby and I'm forgetting the name, Semantic and Toby. Two eye trackers, not now, 15 years back, 2010. Both of them were active. A few years before that, Pointer Research with Stanford University has come out with a nice report on eye tracking. Very difficult, that large context. Next challenge is that I'm just trying to share with all nice faculty members who are attending this lecture, sparing their time to implore into the next spell. Large language is fine, but large context, which human eye does, captures in a flash and goes ahead. That's a challenge we'll have to look into. The higher level perception, we mean how the given input data is categorized. While in low level perception, the processing is mostly bottom up, the output is more or less a function of the input. This is a nice way of talking. I'm not going to the technology, neither am I talking about any specific technology, but addressing what we began with. We know the fundamental problem we are addressing is sensory first. There is no second opinion about it. What we are talking about is perception, which is dependent on what we do with sensory information, not what we like to capture as data. What we want, we capture a lot of things. Since human mind knows how to filter what it doesn't need to solve a task at hand, we thought we will do it ourselves and filter it and say, this is the data, well-defined input data. This is the well-defined output data that I am looking for. Please write a program that transforms this well-defined input data into well-defined output data. Now, we began by challenging that input and output data. It's sensory. What are the types of sensors? It collects a lot of things. To solve a task like a human being, we are not likely to restrict, saying that this is all is the input data, this is all should be the output data. That's a model which we have challenged in a particular topic called AI. And what we could do is simply to address two major topics called hearing and vision, which appeared automatically highly prioritizable, and we were able to come out with devices. AT&T Belcore was doing a great job on vocoders. In fact, 1956 conference had also Claudie Shannon, who was using up the information theory to tell that yes, indeed, it is capturing what is necessary. Very good idea. Hearing, vision. Only two topics we addressed. But what about taste? What about smell? What about touch? Even today, we have the same concerns on haptics. Human touch is something very interesting. Only the two fellows who are touching one another will know what is that touch. Not all can know. How can we describe a shake hand? Please challenge yourselves. What we have addressed is something fascinating. Brilliant large language model We have a value of language, we have a value of thinking. Can machines think? The answer is influenced first by the language, which is perceiving a problem, which is perceiving a solution, which is putting them together and say that, yes, I have solved the problem. But how to make the machine solve the problem? What is that language? What should be that hardware of the machine? What should be the make of that machine? So these are the fundamental problems which kept us agog for 3 decades, the first 3 decades. Hearing and vision, just about 2 topics. We haven't really done much on smell. We haven't really done much on what is called the taste, though I'm aware of an exercise of coming out with an integrated chip that gets the 6 tastes. All foodstuffs which we eat are reducible to only 6 major tastes. So there was an attempt. I was a judge in a project competition, an industry level project competition, that has been talking about this IC, an integrated chip which will analyze the food analyzer that talks about that, which is this much taste is this out of the 6 tastes. Kamna, are we seeing some questions? No, nothing came. All right, good. So what we have been really talking about is whether this is only speech, whether it can be music. The idea of a language is something which we have addressed, which is capturing us. There are many more things. AI was expected to tackle 5 senses, all 5 senses. We have progressed. We have progressed with good research, good verification, good mathematical foundations on hearing, that is speech, and vision on seeing. But next step is learning. That's the game changer. This was the crux of doing, as I mentioned, 5 years back, IBM was there with us at Anna University. Somehow they found that I'm good in AI and ML, and I gotten committed through the university to that group of organizations that came under the aegis of NASCOM. We had a good meeting at Anna University 5 years back. And the next step, perception, is one. We have not really taken that idea of perception to the full steam. Even now in LLM, what we addressed is a language to express what we want to the machine, group of machines built across. Many more things to happen. The real challenges are ahead, but it's fantastic. The large language model is fantastic. They must be congratulated for doing that. Learning, second stage of AI. Artificial intelligence, machine learning, deep learning. This is the hierarchy. What is it that we are talking about? Learning is so important. Learn, unlearn, relearn. That's when we are erudite. We are talking about learnedness. And therefore, we usher in new technologies to create a spell where we all sit down and learn. Pave way for that culture of learning. Machines are learning. Don't worry, all that happened the first 3 to 4 decades of the 70 years of artificial intelligence. The machines are learning. Understandably, the progress is clear. From all those equipment, language, to some extent, learning became the second spell. Is a subset of artificial intelligence focused on algorithms that can learn. Pattern recognition capability. The central premise of machine learning is what if you optimize. But still, this is not a direct answer to the basic question, can machines think? It's still a lively question. We can think because we have 5 senses. Humans can think, is what we presuppose. Training itself is simply a means to an end, generalization. So we want to train. Machine learning has come up with a nice algorithmic approach with a lot of techniques. I will definitely leave the slides with NASCOM. The slide deck may be shared. or even the lecture is being shared on YouTube, Kamna is very resourceful. She sends the YouTube links very immediately after the day's lectures are over. Machine learning, supervised learning, unsupervised learning, reinforced learning. Again, in this particular lecture, I am not really taking into a full PhD level work in AI or learn about half a dozen prerequisite courses, but it is good to know that doing this on ChatGPT or generative AI has strong foundations. While we should be wary about things going wrong, we should be assured that things are not going to be wrong in so bad a manner where we don't have a clue to recover based on the foundation skills. Well articulated papers are there, good research is there, supervised learning, unsupervised learning, reinforcement learning, good models are there for learning. Machine learning was the in thing. I do remember the early days of machine learning where Dr. Tom Mitchell of Rutgers University was championing this idea. Some of those models for classification, can the machine classify? Yes, it can, it's classifying, but limited or aided by the model. How best is the model? Into this, we got the large language. Again, we address the same problem. How do I perceive a problem? How do I perceive a solution? And how do I perceive a way of expressing the solution implied the problem to the machine for it to solve repeatedly on its own? Whenever that problem comes, it should solve. It should not come back to us anymore. Once solved, done. An idea which has fueled the phenomenal growth of computation all over the world. It's done, it's solved, the limitations of the solution are this, the way I perceive the problem is this, the problem has this, the perception of the problem is limited, the perception of the solution is limited, the way I express the solution has been a serious challenge. It has made us spend a lot of midnight hours and then trying to see this code, that code. One small error came in the code, and for a week I don't know what to do. Suddenly one Sunday morning, almost in desperation, I hit the machine, and lo behold, the error is found. The bug is found. It can happen. All programmers attest to this. So is it the language constraint? We solved that problem in a very admirable manner 7 decades after we censored the problem. That's the LLM. Great idea, which is keeping us all occupied. So we are reasonably assured that all this has a strong basis. When things can go, if anything can go wrong, it will go wrong. But we are able to mitigate, we are able to sense by simply becoming vocal. I'm just rephrasing what the CEO of OpenAI spoke. The third stage of AI, deep learning. Deep learning is something which is even more interesting. The subset of machine learning driven by large or artificial neural networks emerged over the past few decades. This is something, which we have been talking about all along. There was an idea called threshold gate. Not now, 80s, 70s, much before 1980s. A threshold gate was so important. What it does is this threshold gate has multiple inputs. When these inputs add on to cross a gating function, the threshold gate will produce a corresponding output. There is a machine built digitally operated network using threshold gates. Do not threshold gates. We have used this idea for modeling a neuron to mimic a human brain. It's all about a sigmoid function that takes several inputs, computes the net essence of those inputs. If it is in tune with a sigmoid function, the neuron is expected to generate an output. Nice idea. Mathematically, it's an easy model because it's easy to build a machine on that. A connectionist approach which has caught on. Please do go back and read Daniel Hillis' work on connection machine. Daniel Hillis is son-in-law of Marvin Minsky. he built this connection machine. And it was a great idea, a connectionist approach where small, simple machines put together. You don't need a supercomputing power that I was talking earlier on. Deep learning got rid of that problem. We don't need a cluster of supercomputers. The learning model is so fantastic that small, simple units, when put together, will give you a better idea. However, it's limited in its approach. The machine learning is a superset of what this is doing. A good, simple mathematical model which broke the dependence on cluster of fascinating machines, high power machines. Small, simple machines with some gating criteria are enough. It's a parallelism. Connectionist approach is massively parallel. So this is the next phase of AI where we said massively parallel processing, MPP. Called MPP, a working model was connectionist model. Daniel Hillis, at a time when he visited India, I had some good interactions way back in early 90s, 88, 90. He was there in India. He formed a organization called Thinking Machines Incorporated, TM Incorporated. But then it was all challenge. It was a good connectionist idea. What he succeeded is not to depend on great high-end machines. For the first time, we came out of the serious requirement of high-end machines for AI, like a Lisp machine, Prolog machine, supercomputing machine, cluster of supercomputing machines. The same idea that kept many people away from AI. Oh, you need a big machine. You need to gain access to that is no more valid. The connectionist machine proved that massively parallel architectures can solve those problems better, but in a deep learning model. That's the first success. I'm not going to spend time on neural networks, but please remember perception, learning, deep learning, all founded on very good, well-established principles, ideas, so that when we are moving into the generative AI, from traditional AI to generative AI, as one of the slides that I was sharing was indicating, we are building that generative AI on good assurance, but it's a breakaway idea. LLM is a very good breakaway idea. When will it become transformative? When the crux of the problem called language is addressed like this, we are quite happy, but then that's not enough. We have to integrate with more sensory ideas. Hearing itself is still limited. What we really addressed is a generative methodology using a large language model. It writes an essay on its own. It writes it on its own, but founded on very good principles. At least we have an early sense of something going wrong. That's the definition of a skill. I am skilled not to simply keep on switching on a same switch every day. If something is going wrong, I should be able to sense it. Blaming technology is not going to take us anywhere. So the human endeavor is necessary. Fourth stage of AI, that is what is keeping all of us occupied today, right now, is the generative AI. It has to become transformative. But how? When is it going to become transformative? So most of you are from teaching, so you may want to understand this approach. Though the topic is ChatGPT, AI in education, and prompt engineering given to me, I am trying to work towards that based on what has happened, why that assurance is coming, why it is a multidisciplinary approach. Even though it is generative, we should somehow communicate to the people that the skill which is founded on this assurance should keep in the back of its mind that if something is slipping out, you should sense it early. That's what is the most important requirement. How to use ChatGPT for systematic literature review. Very difficult to do a systematic literature review to project into next 10 years. What are the questions? that take us into next 10 years, 20 years. So you please go look up this slide again, taking the liberty of going back because there's some difficulty in seeing the slides. My apologies for that. Extremely sorry for that. But this is what we have been thinking about the exercise. The machine languages are there, they are there, and what we need to do is to understand that we are moving from the traditional AI to a generative AI. All that I spoke of is traditional AI. It's built on that good and assurance. But what is expected is ahead. We will have to move towards the generative AI and how to go ahead with that. Systematic literature review, there are tools, many tools for literature review, but then it is still nowhere near putting all this flow of 7 decades of traditional AI. It's putting together some thoughts, but please do understand that it requires all of us. Introduction to generative AI, the basics. Tools like ChatGPT fall under the category of generative AI, which is a subset of broader field of artificial intelligence. ChatGPT is a generative AI-powered natural language processing tool known for its high consistency and relevance. The hit ratio on ChatGPT is very, very high. We will do that comparison a bit later. ChatGPT is a generative AI-powered natural language processing tool known for its high consistency and relevance. While your text here, put your text here, add a detail, just a prompt comes. Add your text. It will give you a great essay on anything that you are talking about. You don't have to put together first 20 results of a search engine. You don't have to go through. It's a cogent narrative as an answer to your query, answer to your prompt. Just give me 1 minute. There is somebody at the door. Sorry, introduction to generative AI, the basics. ChatGPT doesn't require so much of theory about how a language happens, how a natural language happens. Can I add a voice interface, which was there in the first 3 decades? All these attempts were there. All of them should integrate for it to become transformative. We are still not there on the transformative stage. Put your text here, the prompt, the way you choose your keywords, the way the way it generates, everything is nice. It's a fantastic idea which has taken us into a new leap on the AI. But then AI systems can produce new data based on learned patterns to create images. The type of the data is no more concern. It can be in any type. Output type can be text. So what we are really doing is banking on the way we progressed in what we call data: structured, semi-structured, unstructured. It can be audio, it can be video. Where it is getting those lines that are coming on my screen is of no consequence, but is doing a great job. How? By addressing our first major challenge, the language. What we perceive as a problem, what we perceive as a solution, what we perceive as the way we want to express, and how I should pick a language to communicate it to the machine. What I am doing all this so that it does on its own. I am relieved of that problem. I am relieved of that solution. Tomorrow somebody may come, perceive the problem better, perceive the solution better, but that's fine. That's how science progressed all along. So this idea is very good in terms of understanding. Prompt engineering is a way to get the optimal results from ChatGPT by properly defining the specific task and its context. That is where the problem is. Prompt is presently the most used way of defining the context. But what is a human doing in a quick sweep? A large context is picked. Is there a large context model? Prompt is just about the beginning of that idea of building the context. I'm prompting. This is the context in which we want to do, passed on to the chat GPT, irrespective of the type of the data which is relevant to this prompt. That's audio, video, text, image, anything. It is able to give me a very cogent way of working through. The more precise the input parameters of the prompt are, the more accurate. The same idea again. The more precise your command is, the better it is for the machine. The more vagueness, the more what to say, multiple options, ambiguities, difficult. But then prompt has come a long way in specifying some context, but not the large context. This needs an improvement. So we are addressing those two problems in this particular idea called generative AI. Clear task definition, context, style, output format, and how do we interact. Well, I don't have so many things right now. Only two ideas are there. I can add a little bit of a speech. I can add a little bit of vision. That's all is happening right now. Three other senses we are not yet touching. So for it to be transformative, for it to be completely emulating what a human can potentially do, it's the next 20 years. But then we broke the first problem called language, which is very promising. So the way we are talking about design, review, analysis, synthesis, results, update, please keep this cycle in mind. Whatever we are talking about, it starts with something called a text editing and it goes on. There's no second opinion about it. So let's look at a simple exercise, a simple use case that we are talking about. Exercise 1, know the scientist. A chart of scientists, an experiment which we have done, and I'm using it. A chart of scientists is there. Click on any scientist, you'll get a great narrative of it. Just point to that Leonardo da Vinci. It will simply take, I'm choosing Leonardo da Vinci. Please click on that Leonardo da Vinci in this particular chart. The machine senses what you have clicked, takes it up, pushes it, interfaces it very nicely. Please understand the prompt is not a word, it's just a click. We can add more sophistication. We can add speech. We can add a vision and say that something which is beamed randomly, the input device can change. It will give you a great narrative. We tried it for Richard Feynman. We tried it for, it's good. We can have a comparative model. We are not entirely wrong. It is not doing any attribution fallacy. It is not attributing the work of Richard Feynman to Stephen Hawking. Stephen Hawking was another one. Stephen Hawking was another one which we attempted. 3, generated, compared, cross-checked, and then it appears to be fine. But then is there a formal method of doing it? Still elusive. Still elusive. It works. It's doing well. Good hit rate. Of all the generative AI tools, ChatGPT is showing a very good hit rate. But is it assurance enough to proceed? What the ChatGPT has, still we are having concerns. 3 we attempted at one of those project works. Stephen Hawking, Leonardo da Vinci, and Richard Feynman. We tried to generate as much as possible, see if we can construct a formalism, check each and everything that the ChatGPT generated, and then see what is happening. Good consistency, good hit ratio, and it required an automated tool because it generates anything. One click on Leonardo da Vinci, we had a tome coming out. If somebody wants to write a book on Leonardo da Vinci, it's a great idea. So Nobel in literature for an AI tool was a question which we asked for ourselves. Again, as I said, a dozen tools are there to help doing this exercise. And nothing about the PowerPoint presentation is done using the generative AI tools. The anatomy of literature, I can tell. See, I want the output to happen. It's an idea which we attempted, didn't succeed. Lyric. The answer for this prompt should be in a lyric mode, not the text. Something like a poem, something like a song. Still a difficult question. So that's how we should challenge ourselves. It's not merely a catalog of sentences that is throwing out at a remarkable neck-breaking speed. The massively parallel architectures which began in 80s, connectionist machine models, many things are now coming into active use. We are seeing it, we are experiencing it, which were envisaged. So the point is, I don't want the answer in the same text mode. I wish that it comes out as a song. Can I dictate it? Is there a way? Please ask yourselves those questions. I don't want the answer in an essay mode. I want it like a song. Well, it may give a good link. It may give us some good ideas, different forms. Literature is of many types. We tried it for a lyrical idea. Up to some extent, yes, it was coming. So the next idea which we have is where are LLMs? A subset of deep learning. Artificial intelligence, machine learning, deep learning, large language models. So it is founded and is well positioned to give us adequate assurance, but the breakout ideas are still ahead. I would implore all of you to take it back to the students, go through the content, the preparatory lesson plans. They are much better, very, very creative people. The real creators are in front of you in your classrooms. Challenge them. The context is not so good when it is only as a prompt. It should be much more. I need a large context to come out with a solution. Challenge ourselves and see what happens. We can try, we can work it out. 30 transformative applications of generative AI are waiting for that next leap. Today we are on generative AI. The transformative applications, as many as 30. Take every field: healthcare, finance, insurance, retail, gaming. Now we are only talking about education. So keeping the human in the loop, that is where the transformation has to come. It's not enough to simply talk about large context, everything, but how to keep the human adequately in the loop. That skilled fellow who can sense that maybe things are slipping out. Have that sense. So this I'll catch up a little later on that, hoping for transformative. In this many terms I have been talking. I don't want to spend so much time on the slide per se. It's awareness right now. We are beginning to explore with good researchers coming in for the next spell. But however, we are still not fully operational. As I said, the two examples that I gave, one for Know the Scientist, 3 we attempted in a given time and it was showing some good results. Integrated, autonomous, transformative. That's how it is. The focus AI in education must have already gleaned. People are talking about it. Our problems are problems of scale. Suddenly, we want 3 million people to be educated. And Kamna was assuring that this is a kind of a MOOC idea that is experimented with, and we are tracking all the data. Online as a responsive to scale. Very quickly, we can generate a degree program. Very quickly, we can generate a degree program. Modality is not a solution. The 50 degrees that can be generated progression in many fields: governance, risk management. All topics are being covered in this course. Affordable degrees at sale, new phenomena or new hype, old problem. Are we doing better when it is one-on-one tutoring, individualized instruction, immediate feedback, corrective action, or are we doing better in terms of reinventing with something like a massively online program? So we are looking at something that we are talking about as great statistics. Is ChatGPT, generative AI, going to improve all this in manner where we are transforming the idea of learning? That's the promise. LLM usage is a subset of deep learning. It tells personalized learning, student content interactions, student interactions. One of the questions which the book by Henry Kissinger talks about is, who is your best friend? Student content interactions, student interactions, student faculty interactions, a long way to go. The large context is still yet to happen. And the next 4Ds of robotization: dear, dangerous, dirty, and dull. Imagine a robot teaching. I saw a robot model in Japan in 2019 operating a teacher. It works. Dear, dangerous, dirty, and dull. All these are good questions. How long does the paper need to be? Is there an upper page limit to the paper? There are no such constraints offered on ChatGPT. I want the answer in exactly 20 lines. Is there a way of controlling it? I'm simply posing the questions. I'm not reading out these. The essence of what I am communicating is already communicated. The next 1 or 2 minutes, I am simply posing these questions. Transforming curriculum and learning spaces, impact on jobs, impact of curriculum. This is a huge plus. We have a very huge sample of population chipping in: truck drivers, customer service, accountants, lawyers, doctors, teachers. All of them can chip in from wherever they are. The problem of scale is understood in terms of making things accessible. I don't know, Kamna will have to tell what is the statistical result of the earlier course. How many joined, how many cleared, but a bit later. Give me 1 more minute, almost closing. So this is where it is. Need to improve natural language processing, safe learning, creative thinking. Again, we have to challenge ourselves. Next set of questions are not likely to be generated by ChatGPT ready-made. Teacher preparation, we are doing well. Good content will come with Chat quickly, but not so much high grade to further research, give research directions, is what I would think, what I would surmise. Cultivating ethics includes a challenge, but it helps. We know, we are aware, and then we should know that what is innovation. This is something which is there for records. It's envisaged in 2021, the 2 billion market. We are not yet there. Why? 4 years after 2021, we are not yet there. Please ask yourselves those questions, and with 4 minutes to spare, I would halt and promise that the slide deck will be there with NASCOM very soon, and Kamla is very resourceful. She'll send the YouTube. Extremely sorry that we missed out a few slides, 4 or 5 slides in the beginning. Thanks.
Thank you so much for that session, sir. It was amazing. And once you share the deck with me, I will share it with all the participants in the WhatsApp group. So couple of things from my side. Last faculty cohort which you attended, you had a question. We had 120 registrations, out of which 62 passed the certificate, the assessment. And for this particular cohort, we have almost 321 registrations. Almost 200 people participated in the session today. And hopefully more people will join in as the days progress, because we are having a total count of 321 who have registered for this session. And I will request all the participants to share the WhatsApp group and add your colleagues if they have not got the welcome email from Future Skills Prime. That may have gone in your spam boxes or in your junk folders. Please check and log into the Future Skills Prime portal, complete this module of generative AI fluency. In a day or two, we'll also be sharing some promo codes with you. Please don't spend any money for the assessment. We will be sharing coupon codes. Feedback link I will share on Saturday. And then you also have to give your feedback on the Atal portal. So I'll be sharing a final feedback link on Saturday. So thank you everyone for your participation, and look forward to the session tomorrow, and see you all tomorrow at 6 o'clock. Thank you. Thank
On
you,
time,
Dr.
I
Gopal.
suppose. Thank you, madam. I'm on time, I suppose, to close
Yes,
this. Thank you so
absolutely,
much.
sir. Very well on time, as usual. Thank you
Thank
so
you.
much. We will share the PPT, and
Yes.
the link is here, guys. For your Future Skills Prime, I have posted the link. Please log in. Please check your email spam folders and complete the course, because the assessment will take place on the Future Skills Prime portal. Venkata Nandini ji, please check your email. We have sent emails to everyone. Check your inbox, spam folder, junk folder. You will get it. And I'm surprised that you're not able to share your video, because I have enabled the video. I don't know why it's not. I'll have to check with the team and I'll come back. Thank you so much. We'll close the session today almost on time. Thank you.